comet that has stolen headlines is not the one that matters. The visitor with a strange orbit and exotic chemistry makes for good conversation. It sparks speculation about alien origins and hidden intentions, and it fuels late-night debates about the unknown. But it's not the thing that keeps planetary defense experts awake at night. The truth is that while our attention drifts toward the strange interstellar objects racing through the solar system, the real danger comes from something much closer, something already charted, something with a date that can be circled on a calendar. Its name is Apophis, and on April 13th, 2029, it will pass so close to Earth that our satellites will look outward and see it drifting across the sky faster than an airliner, visible to the naked eye as it sweeps between our planet and the belt of orbiting machines we rely on every day. This is not a hypothetical projection centuries away, not a scenario buried in abstract probability tables, not a piece of cosmic speculation we can dismiss as entertainment. This is an event we can time down to the minute, calculate with staggering precision, and watch unfold in real time. The difference between fascination and fear lies in the simple reality that this object is not an outsider from a distant star system, but a long-term resident of our solar system, a piece of rock large enough to erase cities, close enough to graze the region where human technology circles the planet, and important enough that its future path may define the way we think about planetary defense for the rest of this century. Apophis was discovered in 2004, a speck of light tracked by telescopes that slowly revealed itself as a near-Earth asteroid, roughly 340 meters across. That is not enough to end human civilization in a single impact, but it is enough to level entire regions, trigger tsunamis across oceans, and alter global climate for years. Within months of discovery, early orbital calculations indicated something extraordinary. The probability of impact with Earth in 2029 was estimated at nearly 3%. For astronomers accustomed to odds measured in fractions of fractions, numbers so small they might as well be zero, a 3% chance was shocking. For weeks, it was the most dangerous object ever tracked. Scientists adjusted models, checked for errors, refined data, and confirmed that yes, for the first time in modern history, humanity had found a rock with a real chance of colliding with Earth within our lifetimes. That chance was later ruled out. More precise tracking and additional observations showed that 2029 itself would not bring a collision. The asteroid would pass close, terrifyingly close, but not close enough to strike. This should have been the end of the story, but it wasn't. Because the way orbital mechanics works, a near miss is not the same as safety. The gravitational field of Earth can twist a trajectory just enough to turn a future miss into a future strike. In the case of Apophis, there exists a narrow corridor of space called a keyhole. If the asteroid passes through this keyhole in 2029, only a few hundred meters wide, its orbit will be altered with surgical precision to line it up for a direct collision in 2036. The concept is unsettling. A rock nearly 1,000 feet wide moving at cosmic velocity, guided not by intelligence but by the blind pull of gravity, could be forced into an orbit that would bring it directly into our path. The idea of the keyhole highlights the fragility of reassurance. Officials can say with confidence that no impact will occur in 2029, and technically they are correct. But the comfort ends when one considers what lies beyond. The asteroid's passage will be so close, so dramatic, that small uncertainties in its shape, spin, and exact trajectory could cascade into long-term predictions we do not fully control. Scientists stress that the chance of a later impact has been reduced, that current calculations suggest the risk of 2036 is essentially negligible. But even if the numbers now favour safety, the principle remains haunting. One close approach can set up the next. One near miss can be the rehearsal for the real strike. The fascination with interstellar visitors like Atlas is understandable. They are new, exotic, mysterious. They ignite speculation about alien probes disguised as comets, or strange chemistry hinting at artificial design. But those objects arrive on hyperbolic orbits, moving too fast to be captured by the sun, destined to pass through and vanish forever. They can scare us in the imagination, but mathematically they are harmless. Apophis is the opposite. It is mundane, a chunk of rock and metal from the asteroid belt nudged inward by gravitational interactions, but it lingers, bound to the same star as we are, crossing paths with our orbit again and again. It does not leave, it waits. The real threat is not the alien, but the familiar. Not the comet streaking through the dark on its way out of the solar system, but the asteroid that returns again and again like a predator circling its prey. And what makes this worse is the precision of the calendar. April 13th, 2029 is not speculative. It is scheduled. On that day, billions of people will be able to look up and see an asteroid with the naked eye, brighter than many stars, moving fast enough to be unmistakable. No telescope required. It will not feel like a distant scientific curiosity. It will feel like a close encounter. And it will be a reminder that our planet lives in a shooting gallery. The psychological weight of that event is difficult to overstate. For decades, planetary defense has been treated as an abstract problem. The dinosaur-ending impact of 65 million years ago was too far in the past to feel urgent. The Chelyabinsk meteor of 2013, which exploded over Russia with the energy of half a megaton bomb, injured more than 1,000 people and shattered windows across 6 cities. But it was small, a reminder rather than a catastrophe. Apophis changes that scale. It is big enough to matter globally and close enough to be undeniable. When it sweeps across the night sky in 2029, it will be a spectacle, a warning, and a question all at once. What are we prepared to do? Are we ready to deflect such an object if it were on a collision course? Do we have the technology, the coordination, the political will? These are not questions for science fiction. They are practical questions of engineering, diplomacy, and survival. And the unsettling answer is that we are not ready. NASA has a Planetary Defense Coordination Office. Telescopes scan the skies nightly for new threats. Studies are being conducted on deflection methods using kinetic impactors, gravity tractors, or even nuclear devices. But none of these methods have ever been tested on a real asteroid of this scale. None of them have been proven in the kind of scenario that would leave only years to respond. We have ideas, simulations, proposals. We do not have certainty. Apophis embodies the tension between reassurance and paranoia. On the one hand, scientists can state with confidence that it will not hit in 2029. On the other, the fact that it will pass closer than our satellites, that it once carried a measurable chance of impact, and that it still has keyholes for future encounters, makes it impossible to dismiss. The asteroid is both safe and dangerous, both an astronomical event and a potential future catastrophe. The contradiction is what makes it unsettling. The numbers say we can relax. The image of a massive rock sliding between Earth and orbiting satellites says otherwise. The worst-case scenario is not interstellar, it is local. It is not about comets from other stars, but about asteroids already here, hiding in plain sight, waiting for orbital mechanics to line up. Apophis forces us to face this truth. The danger is not the visitor from outside. The danger is the rock that does not leave, the one that circles back, the one that has an appointment with our world on a date already marked. And as we prepare for that night in April, the question is not whether we will survive the flyby. The question is whether we will learn what it truly means to live on a planet that is vulnerable to the sky. Atlas isn't the problem. That phrase may sound dismissive, almost reckless, when so many headlines have built it up into something mysterious, something possibly artificial, something worth staying awake at night to ponder. But when we step away from speculation and focus on what matters most in terms of danger, the truth is unavoidable. Atlas, like the interstellar objects before it, is not a threat. Its hyperbolic orbit guarantees it will not linger in our neighbourhood. Its speed is so high that no gravitational tug from the sun will capture it. It will pass through and vanish, never to return. Even its odd chemistry, its strange ratios of carbon dioxide to water, however intriguing, remain curiosities for astronomers rather than dangers for anyone living on this planet. What unsettles us about Atlas is its unfamiliarity. But unfamiliar does not mean dangerous. If anything, its strangeness distracts us from what is actually dangerous, from the threats that come not from beyond the stars but from within our own solar system. The human brain has always been fascinated by the alien and the unusual. A mysterious object from another star system ignites imagination because it feels like contact, or at least the edge of contact. We project intelligence into its trajectory, purpose into its chemistry, intention into its speed. It becomes a mirror for our anxieties about whether we're alone, about whether someone else might already be watching. But when the numbers are laid out, when orbital mechanics is allowed to cut through paranoia, Atlas collapses back into what it is, a rock and ice fragment travelling too fast to touch us. Its closest approach is measured in hundreds of millions of kilometres, distances so large that Earth will never even graze its tail. Yet the coverage, the speculation, the documentaries frame it as though this is the moment to worry. That misplaced focus is exactly the problem. Because while our eyes are turned outward to the interstellar, something else is coming from within. Something that will not pass harmlessly into the void. Something we already know will approach with terrifying precision. That something is Apophis. Unlike Atlas, Apophis is not an unknown interloper. It has been tracked for decades. Its orbit is mapped with precision down to fractions of a kilometre. Its size is not speculation but measurement, roughly 340 metres across. We know its date of arrival, April 13th, 2029, and we know its path will take it closer to Earth than many satellites. There is no hyperbolic escape for this rock. It is bound to the sun. It circles back. And this, more than any exotic visitor, is what makes it dangerous. Not because it will definitely hit, but because it is locked into the same gravitational system as we are, forever crossing and recrossing our path. Atlas cannot return. Apophis always will. The difference between harmless and hazardous is not always intuitive. To most people, the idea of an object from another star system feels inherently threatening. Something so alien must surely carry more risk than something familiar. But orbital mechanics reverses that intuition. The farther something comes from, the less likely it is to stay. The closer something originates, the greater the chance that it will cross us again. Atlas, Oumuamua, and Borisov are tourists. Apophis is a neighbour, and neighbours are the ones who show up uninvited. In 2004, when Apophis was first discovered, astronomers quickly realised its orbit intersected Earth's in a way that made a collision possible. The initial calculations suggested a nearly 3% chance of impact in 2029. To the uninitiated, that may sound small, but in the language of planetary defence, it was enormous. These objects almost always resolve into safety once additional data refines their path. Probabilities drop to 0, but 3% is not background noise. It was enough to trigger emergency meetings, enough to classify Apophis as the most dangerous asteroid ever observed. That first wave of alarm has since subsided. We now know 2029 will be a flyby, not an impact. But the shadow of those early probabilities still lingers because it revealed how fragile our certainties can be. Atlas commands attention precisely because it is novel, but novelty is not the metric we should use when evaluating risk. The metric is orbital dynamics, and dynamics tell us that Apophis, not Atlas, is the object that deserves our focus. The public fascination with interstellar wanderers distracts from the grinding statistical reality that Earth is constantly crossing paths with objects large enough to matter. The Chelyabinsk meteor in 2013 was 20 meters across and exploded in the atmosphere with the energy of a half-megaton bomb. It injured over 1,000 people without ever touching the ground. Apophis is more than 15 times larger. Its energy on impact would be orders of magnitude greater. And unlike the surprise of Chelyabinsk, Apophis comes with a countdown clock. When April 2029 arrives, people across Europe, Africa and Asia will be able to look up at the night sky and see Apophis streaking by. No telescope required. It will be visible to the naked eye, brighter than many stars. For the first time in human history, an asteroid of this size will pass between Earth and the Moon, in fact passing inside the ring of geosynchronous satellites. That proximity alone shifts the conversation. This will not be a story confined to scientists and specialists. It will be a global event, broadcast live, visible to billions. And when something so large, so obvious, sweeps that close to Earth, reassurance becomes difficult to sustain, no matter how many official statements insist it poses no danger. The real tension lies in what happens after. The 2029 encounter will not be the end. Apophis's trajectory is sensitive to gravitational nudges. The Earth itself will alter its orbit slightly during the flyby. If it passes through a narrow corridor of space, a so-called keyhole only hundreds of meters wide, that small adjustment could set it on a path to collide with Earth in 2036. Current measurements suggest this scenario is unlikely, vanishingly so according to updated models, but the principle remains. One pass sets up the next. One near miss can lay the groundwork for a future strike. And that is why Atlas is not the problem, because Atlas leaves while Apophis returns. Even if Apophis never strikes Earth, its close approach forces us to confront a reality that has been easy to ignore. We live on a planet in a cosmic shooting gallery. Tens of thousands of near-Earth objects have been catalogued, and new ones are discovered constantly. Many are small, but hundreds are large enough to cause regional devastation. We track them, model their orbits, and reassure ourselves with percentages. But probabilities are not guarantees. The Tunguska event of 1908 levelled 2,000 square kilometres of Siberian forest. It was caused by an object less than 50 metres wide. Apophis is 7 times that size. Atlas, with all its mystery, cannot touch us. Apophis, with all its familiarity, will brush past us so closely that we'll feel it in our nerves, in our instincts, in our sense of vulnerability. This is the paradox of planetary defence. The things that frighten us are not the things that threaten us. The real threat comes from the ordinary, the predictable, the catalogued rock whose orbit crosses ours again and again. When the night of April 13th arrives and Apophis streaks across the sky, there will be no need for speculation about alien technology, no debate about comet chemistry, no wondering whether this visitor is a probe. It will be a massive rock, moving with terrifying speed, passing closer than satellites that power our communications, our weather forecasts, our navigation. And the spectacle will force the public to ask questions that scientists have been asking quietly for years. Are we ready to deflect such an object? Could we? Do we have the technology, the coordination, the political will? These are not questions inspired by Atlas. They are questions demanded by Apophis. This is why Atlas isn't the problem. Because fascination with Atlas is indulgence, while recognition of Apophis is survival. The interstellar visitor is exotic distraction. The near-Earth asteroid is a test of whether we can act in time. One will leave and never return. The other will circle back again and again until eventually, whether in a century or 1,000 years, one of its descendants, one of its kin, or perhaps Apophis itself, finds the wrong side of probability. And when that day comes, what matters is not how much attention we gave to strange objects from other stars, but how much preparation we made for the rocks already here, waiting, circling, inevitable. The date already on the calendar is not some vague projection lost in the haze of the distant future. It is not an abstract point in orbital models centuries away, where probabilities vanish into insignificance. and human civilization will almost certainly have changed beyond recognition. It is a date in less than a decade, a date already printed on calendars and already creeping toward us with every rotation of the Earth. April 13th, 2029, a Friday. A day that will become one of the most extraordinary in human history, not because of anything we will do, but because of what will pass us by. On that night, Apophis will make its closest approach to Earth, and for the first time in recorded history, an asteroid large enough to change the world will sweep so close that billions of people will be able to look up and see it with their own eyes. This is not a speculative maybe. This is a confirmed event. Astronomers have been tracking Apophis for 2 decades, refining its orbit with radar imaging, telescopic observations, and precise astrometric measurements. Every adjustment brings the same conclusion. The asteroid will pass within 31,000 kilometers of Earth's surface. That is closer than the geosynchronous satellites we rely on for communication and navigation, closer than the weather satellites that track storms, closer than the orbital highways we have built around our planet. The asteroid will dive through that zone, a 340-meter-wide rock moving at more than 30 kilometers per second, glowing in reflected sunlight, bright enough to be seen without equipment. The sheer proximity of this event makes it unlike anything humanity has experienced. We have seen asteroids pass near Earth before, sometimes coming within a few 100,000 kilometers. We have even had small rocks, the size of cars or buses, explode in the atmosphere, startling but not catastrophic. But never has something this large come this close. The last time an object of comparable size struck Earth was 66 million years ago, when the Chicxulub impact ended the reign of the dinosaurs and reset the course of evolution. That asteroid was larger, several kilometers across, enough to trigger global climate collapse. Apophis is smaller, but still powerful enough to destroy a city, to devastate a region, to cause human casualties on a scale we have never experienced. And on April 13th, 2029, it will not be hypothetical. It will be right there, sliding between us and the satellites, a cosmic bullet that misses, but misses so narrowly that the world will hold its breath. The calendar matters because it turns speculation into schedule. People are used to scientists warning about probabilities in abstract terms. A 1 in a million chance over the next century. A remote possibility sometime in the next few thousand years. Those phrases are easy to ignore because they are too far removed from daily life. But April 13th, 2029 is not remote. It is closer than the Olympic Games scheduled for the next decade, closer than many political cycles, closer than the career arcs of millions of people alive right now. Children in school today will still be young adults when it happens. People making plans for the 2030s already know that Apophis will have passed before those plans unfold. This makes it real in a way that statistics cannot. The strangeness of this date is amplified by its cultural resonance. It falls on a Friday the 13th, a date already saturated with superstition. That coincidence will not be lost on the public. No matter how carefully scientists explain orbital mechanics, no matter how many times they emphasize that the asteroid will not strike, the symbolism of Friday the 13th will hang over the event. It will become a global spectacle, a night of anxiety and fascination, a night when people gather outside to look up and wonder whether the sky is friend or enemy. The truth is that scientists have every reason to believe the asteroid will pass safely. Decades of tracking have reduced the uncertainties. Radar images from facilities like Goldstone and Arecibo before its collapse mapped the asteroid's shape and spin. Observations refined its orbit to extraordinary precision. The keyhole scenario that once raised the spectre of a 2036 impact has been effectively ruled out by new data. The official line is clear. There is no danger in 2029, and no danger in the immediate decades beyond. But this is where the tension between certainty and paranoia surfaces again. Because even as scientists present their reassurance, the sight of a 340-meter-wide asteroid passing between Earth and its satellites will not feel safe. It will feel like a warning. The difference between safety and danger in orbital mechanics is measured in kilometres. The asteroid will miss Earth by tens of thousands of kilometres. That sounds large, until you realise that the Earth itself is 12,700 kilometres wide. In cosmic terms, the margin is razor thin. If Apophis were shifted by less than 1 Earth radius, the story would be different. And the unsettling part is that this razor-thin margin is not a one-time anomaly. Earth crosses paths with asteroids constantly. This is simply the closest encounter we have tracked with such a large object. The reality is that eventually, whether it is Apophis or another asteroid, one of these encounters will not be a miss. April 13th, 2029 becomes a test not just of astronomy, but of psychology. How will humanity react when the abstract risk of asteroid impacts becomes tangible, visible, undeniable? Will we treat it as a wake-up call, a moment to invest in planetary defence, to build real systems for deflection and detection? Or will we treat it as another near miss, breathe a sigh of relief and move on, only to be unprepared when the next object lines up on a collision course? The answer will reveal how seriously we take the existential risks that do not fit neatly into political cycles or quarterly profits. The date also matters for science. Astronomers will use the flyby to study Apophis in unprecedented detail. Telescopes across the world will track its brightness, its spin, its thermal properties. Radar systems will map its surface down to meter-scale features. Space agencies are already discussing the possibility of sending missions to intercept it, to ride alongside it, to measure it directly during the encounter. The opportunity is extraordinary because the asteroid will be so close that even small telescopes, even amateur astronomers, will be able to contribute data. The global network of observation will be unparalleled. For planetary science, it will be a once-in-a-lifetime opportunity to study a near-Earth asteroid in detail. For planetary defence, it will be a rehearsal, a chance to test coordination, communication, and public response in a real-world scenario. The date is fixed, but the meaning we assign to it is not. To some, it will be an exciting night, a chance to witness a celestial spectacle unlike any other. To others, it will be a night of anxiety, a reminder of how vulnerable we are to the sky. For scientists, it will be data. For governments, it may be a public relations challenge, a balancing act between reassurance and honesty. For the world as a whole, it will be a moment that forces us to remember that Earth is not isolated. We live in a solar system filled with rocks on unstable paths, and every so often one of them comes too close. The most dangerous aspect of April 13th, 2029 may not be the asteroid itself, but the complacency it could produce. If Apophis passes safely and nothing happens, many will conclude that the threat of asteroid impacts is exaggerated, that planetary defence is unnecessary, that the scientists crying danger are overstating the case. That would be the wrong lesson. The correct lesson is that we got lucky this time, and luck is not a strategy. The fact that Apophis will pass within geosynchronous orbit and not strike is extraordinary fortune. To use that as an excuse for inaction would be to misinterpret reality in the most dangerous way possible. The calendar gives us certainty, but certainty cuts both ways. We are certain Apophis will not hit in 2029, but we are also certain that eventually some asteroid will. The laws of probability guarantee it. The Earth has been struck countless times before. The scars are written across its surface in craters, some small, some hundreds of kilometres wide. The only question is when the next one will come, and whether we will be prepared. April 13th, 2029 is a date that forces us to confront that inevitability. It is a countdown we cannot ignore. It is not speculation or imagination. It is the day an asteroid large enough to matter will pass through the space between our planet and its satellites, and the world will watch. The spectacle will end, the asteroid will move on, and Earth will remain untouched. But the memory will linger. And the question will hang in the air, unspoken but unavoidable. What about next time? Apophis is not just an asteroid with a number in a catalogue. It is not just 99942 in the endless sequence of minor planets tracked across the solar system. It carries a name, and that name carries weight. When astronomers first discovered it in 2004, the rules of naming required something more than a sterile designation. The choice they made was not arbitrary. They named it after an ancient deity, one that symbolised chaos and destruction, a god from Egyptian mythology known as Apep, or Apophis, the serpent that threatened to swallow the sun each night and plunge the world into darkness. The myth was not chosen casually. It was chosen because even in its earliest days, this asteroid was already associated with fear. The cultural resonance of that name is impossible to separate from the object itself. For thousands of years, humanity has told stories about cosmic threats, about dragons in the sky, about serpents that devour worlds, about gods who wield destruction from above. To give this asteroid the name Apophis was to link it to that long history of fear. The ancient Egyptians saw the serpent as the eternal enemy of order, a creature that Ra, the sun god, had to defeat every night to bring dawn again. Every sunrise was a victory against annihilation. Every new day was proof that chaos had been held back, but only for a time. Apophis was never truly destroyed. It always returned, always waited for another attempt to end the cycle. That myth resonates disturbingly well with the orbital mechanics of a near-Earth asteroid. It is not here once and gone forever. It comes back again and again, waiting for the wrong alignment, waiting for the day when gravity tips the balance. When the asteroid was first calculated to have a small chance of impact in 2029, the name felt prophetic. The idea that a serpent of stone and metal was racing toward Earth with a date attached gave headlines a kind of apocalyptic certainty. It captured imagination because the symbolism was so clear. Humanity, for all its technology, still lived under the shadow of cosmic chaos. We had radar dishes and telescopes, computers and simulations, but none of those changed the fundamental truth that a rock from space could still end cities or worse. Giving it the name Apophis was like admitting that for all our progress, the ancient myths were still relevant. The dragon in the sky still existed. The serpent still coiled through the heavens. The psychological power of a name cannot be underestimated. When an asteroid is called 1997 XF11 or 2000 SG3344, it feels technical, distant, unthreatening. Numbers make things abstract. They strip away the emotional connection. But when an asteroid is called Apophis, the imagination cannot help but fill in the rest. It becomes a character, not just an object. It becomes an enemy, not just a rock. And that changes how people think about it. The fear becomes tangible. The headlines write themselves. The myth of Chaos Serpent and the science of orbital mechanics intertwine into something that resonates far beyond astronomy. This resonance is amplified by the date. April 13th, 2029, falling on a Friday the 13th, creates a perfect storm of superstition. In the modern world, Friday the 13th is a date associated with bad luck, with fear, with horror films and cultural anxiety. Linking Apophis to that date gives it an almost theatrical edge, as though the universe itself were staging a demonstration of how fragile our sense of safety really is. Scientists may dismiss superstition, but they cannot control public perception. When billions of people look up on that night and see Apophis streaking across the sky, many will not see orbital mechanics. They will see prophecy fulfilled. They will see chaos incarnate. They will see the serpent returned. The choice of the name Apophis also reflects something deeper about the way humans confront existential risk. We frame threats in the language of mythology because myths are how we process fear. Long before anyone understood impact craters or orbital mechanics, ancient cultures looked at scars on the Earth, at strange lights in the sky, at sudden disasters, and explained them with stories. Dragons, serpents, gods of war, celestial hunters, all were attempts to make sense of forces too large to comprehend. The modern world has more precise explanations, but the instinct remains. we still give names that tie cosmic threats to ancient archetypes because it helps us emotionally grasp their significance. The asteroid could have been named after a scientist or a random location, but calling it Apophis was an act of honesty. It acknowledged that what we felt about this rock was not curiosity alone, it was fear. There is a kind of irony in how this name now shapes public understanding. Scientists work hard to separate myth from reality, to present data as numbers and probabilities, to explain that Apophis will not strike in 2029, yet the very name makes that task harder. People hear Apophis and think of destruction. They hear Friday the 13th and think of disaster. The name has created an emotional narrative that science alone cannot fully counter. It is not that the public misunderstands, it is that they interpret through myth as much as through mathematics, and in truth, that interpretation may not be entirely wrong. The serpent in the myth was not defeated forever. It was always returning, always waiting. In the same way, Apophis will not vanish after 2029. It will continue to circle back, again and again, reminding us that the battle between order and chaos is never complete. This is what gives the name its weight. It is not just a label. It is a reminder of humanity's place in a universe that does not guarantee safety. Apophis symbolizes the thin line between survival and destruction. It embodies the idea that even in a world of satellites and space stations, we remain vulnerable to the sky, and it forces us to confront the uncomfortable truth that while interstellar visitors like Atlas may fascinate us, it is the bound, recurring rocks like Apophis that will define our future. When Apophis sweeps past Earth in 2029, it will not simply be a scientific event. It will be a cultural event, a mythological event, a psychological event. People will look up and see not just a rock, but a story playing out, a story as old as civilization itself. The serpent will pass through the sky, chaos will threaten order, and humanity will watch, waiting to see if dawn comes again. The weight of the name also influences the way governments and institutions treat the asteroid. It is not just another object on a long list. It is a high-profile risk, a public relations challenge, a test of how planetary defense is communicated. Scientists must walk a fine line between reassurance and honesty, between explaining that there is no impact in 2029 and acknowledging that impacts in the future are inevitable, if not from this asteroid, then from another. The myth amplifies the stakes. To downplay Apophis risks looking like denial. To emphasize it risks causing panic. The name itself makes balance difficult. But perhaps this is the value of the name. It prevents complacency. It forces the public to pay attention. Numbers alone rarely motivate action. Names, myths, stories, those are what make people care. And if caring leads to investment in planetary defense, in telescopes, in deflection technologies, then the myth will have served a purpose. The ancient serpent may yet protect us, not by swallowing the sun, but by reminding us that vigilance is the price of survival. When the day comes and Apophis glides across the sky, the world will not be watching 99942. It will be watching Apophis, the chaos serpent, the asteroid that embodies both myth and mathematics. And in that moment, the weight of the name will matter as much as the calculations, because names shape how we think, and how we think will shape whether we prepare. In the winter of 2004, two astronomers working at the Kitt Peak National Observatory in Arizona were conducting routine surveys of the night sky. These surveys were part of an effort that had been going on quietly for years, designed not to find beauty in the heavens, but to catalogue potential dangers. The Near-Earth Object Survey programs were tasked with identifying asteroids and comets that could cross Earth's orbit. The work was repetitive, systematic, often dull. Each night, telescopes swept the same patches of sky, looking for faint points of light that shifted ever so slightly against the background stars. It was in this repetition that something new appeared. a moving speck that didn't match anything in the catalogues. The object was designated 2004 MN4. At first, it was just another asteroid, one more dot added to the growing list of minor planets discovered each year. But as soon as follow-up observations were gathered and orbital calculations began, the mood shifted. This was not just another asteroid. This one had an orbit that crossed Earth's. Its trajectory was troubling, and within weeks, it became clear that the usual reassurances could not be given. Early calculations are always imprecise. Astronomers need days, weeks, sometimes months of observations to pin down the exact path of a newly discovered object. The more data, the tighter the orbit. With only a handful of images, the uncertainty is huge, but even with those uncertainties, 2004 MN4 stood out. The probabilities kept pointing in the same direction. There was a measurable chance, higher than anything seen before, that this asteroid could strike Earth on April 13, 2029. The numbers at first were rough, 1 or 2%. As more data came in, the probability was refined upward. At its peak, the chance of impact was listed at nearly 3%. For context, most near-Earth asteroids with initially alarming orbits are downgraded almost immediately. Probabilities drop to 0 within days as more observations come in, but this one held steady. The number 3% may not sound large, but in the realm of asteroid impact risk, it was astronomical. It was the difference between a non-event and a potential catastrophe. The astronomical community was shaken. Nothing like this had ever happened in modern times. The Torino scale, a system designed to classify impact threats from 0 to 10, had never been tested in public consciousness. Most discoveries hovered at 0 or 1, harmless. Suddenly, 2004 MN4 was rated at level 4. That meant a close encounter with a real chance of collision capable of causing regional devastation. No asteroid had ever been rated so high before. The public didn't know it yet, but in observatories and planetary defense offices around the world, alarm bells were ringing. The panic wasn't loud at first. Scientists are cautious, careful with their words. They avoided sensationalism, but within their own circles the conversations carried an edge of disbelief. Was this finally it? The scenario they had spent careers preparing for? The one where an asteroid large enough to destroy a city or worse was on a path to Earth within their own lifetimes. The calculations were public, so anyone with the software could verify them. And sure enough, amateur astronomers and professionals alike began running the numbers. The conclusion was the same: a small but real chance of impact in 2029. The public learned about it soon after, and headlines spread quickly. For the first time, a specific asteroid had a date attached to it. This wasn't a vague sometime in the next 1,000 years. This was an April night, 25 years in the future. People could look at their calendars, circle the date, and wonder whether they or their children would be alive to see it happen. The press gave it a name, and soon the official name followed. 2004, MN4 became Apophis, and the mythology attached itself to the science. The panic grew because this was new territory. Humanity had never faced such a scenario before. We knew asteroid impacts happened. We had the evidence written in craters around the world, in the extinction of the dinosaurs, in the Tunguska event. But those were the past. The future had always felt abstract. Suddenly it wasn't. Suddenly there was a real countdown, and the countdown was short. Governments quietly began paying attention. Planetary defense was a fringe topic in the early 2000s, not a major priority. Budgets for asteroid surveys were limited, often debated and cut. The idea of spending money to prevent something that might happen in 1,000 years did not appeal to politicians. But Apophis changed the conversation. NASA, ESA and other agencies scrambled to refine the orbit, to fund additional observations, to calm the public without dismissing the risk. The Planetary Defense Coordination Office, which would later become official, began to take shape in response to exactly this kind of scenario. It was Apophis that forced governments to confront the idea that asteroid impacts were not just ancient history, they were future events waiting to happen. The panic reached its peak when simulations began to circulate showing what an impact might look like. A rock 340 metres across, travelling at 30 kilometres per second, would release the energy of thousands of nuclear bombs. If it struck land, an entire region could be levelled. If it struck ocean, the tsunamis would be global, flooding coastlines, devastating cities. The impact wouldn't end civilization, but it would be the greatest disaster in human history. Millions could die. Crops could fail from the dust and smoke. Economies could collapse. Even if humanity survived, the world after would be scarred for decades. These were not fantasies. They were sober calculations from scientists who had spent their careers modelling such scenarios. The fact that the probability was only 3% did little to calm nerves. 3% meant a 97% chance of safety, but safety is not what people focus on when extinction is the alternative. The headlines didn't say, 97% chance Earth will be fine. They said, asteroid may strike Earth in 2029. Fear is not balanced by numbers. Fear feeds on possibilities, and the possibility was real enough to matter. As the months passed and more observations were gathered, the panic began to ease. Each new measurement tightened the orbit, reducing the uncertainty. Slowly, the probability of impact dropped. By the summer of 2005, astronomers were able to declare that Apophis would not hit Earth in 2029. The danger had passed. But the relief was not complete, because even as they announced that 2029 would be a flyby, they also acknowledged something else. If Apophis passed through a narrow gravitational keyhole during that encounter, only a few hundred metres wide, its orbit could be altered just enough to bring it back on a collision course for 2036. The serpent wasn't gone, it had simply been delayed. This shift from 2027 to 2036 was almost worse for public perception. At first, there was clarity. Danger in 2029 now removed. But then came uncertainty again. Danger in 2036, possible but unknown. It was like pushing back the date of a trial. The reprieve was temporary, the anxiety still present. For years afterward, Apophis was listed on NASA's Century Risk table as the most dangerous object in the solar system. Its name became shorthand for the reality of asteroid risk. The panic had receded, but the unease remained. Looking back, that first wave of fear was a turning point. It showed how fragile our sense of security is when faced with something as impersonal and unstoppable as a rock from space. It revealed the gap between scientific caution and public imagination. And it forced the world to take planetary defence seriously, not as a theoretical exercise, but as a matter of survival. The panic of 2004 may have faded, but its echo continues. Every article about Apophis today still references that first discovery, those first probabilities, that first moment when the world realised an impact was possible within our own lifetimes. It is a story that will follow the asteroid forever, no matter how many times the risk is downgraded, no matter how many new observations refine its path. The memory of that panic is part of the object's identity, part of the reason its name carries such weight, and when it finally appears in the night sky in 2029, when billions watch it streak past Earth, that memory will return. People will remember that once, not so long ago, Apophis was thought to be the one. The panic of discovery will colour the spectacle of the flyby, making it more than just an astronomical event. It will be a reminder that the serpent once coiled close enough to strike, and that someday another one will. For scientists who have spent their careers tracking rocks in space, 2029 is not just another year. It is the year that has been etched into their minds since the winter of 2004, when the discovery of Apophis first rattled the quiet confidence of planetary defence. Even though the numbers today say the world is safe, even though the refined orbit removes the impact risk for that year, April 13th continues to haunt them. It is not superstition. It is not mythology. It is mathematics, physics, and history, combining into a single night when the line between reassurance and catastrophe will be thinner than it has ever been in modern times. The haunting begins with proximity. When Apophis makes its closest approach, it will come within 31,000 kilometres of Earth's surface. For people unfamiliar with orbital distances, that number may seem meaningless, but for astronomers it is staggering. The Moon orbits at roughly 384,000 kilometres. The International Space Station circles at about 400 kilometres. Geostationary satellites, the ones that hold our communications, weather and GPS systems in place, sit at about 36,000 kilometres. Apophis will dive beneath them. It will pass closer than many of the machines we depend on every day. This fact alone makes 2029 unforgettable. The Earth is a large target in cosmic terms, and for an asteroid this size to thread the needle so precisely without hitting feels like defiance of odds. Scientists trust their calculations, but calculations are not the same as peace of mind. The haunting deepens with history. Humanity has been struck before. 65 million years ago, the Chicxulub impact reshaped the biosphere and ended the dinosaurs. 50,000 years ago, a smaller impact carved the Barringer crater in Arizona, nearly a kilometre wide. Just over a century ago, the Tunguska event levelled 2,000 square kilometres of Siberian forest, and in 2013, a 20-metre meteor exploded over Chelyabinsk, injuring over 1,000 people without ever reaching the ground. These are not rare events in geological terms, they are inevitabilities. The scars of impacts are written across every continent. To know this history and then watch a rock 340 metres wide skim past Earth is to feel the weight of inevitability pressing close. Scientists also know how fragile our predictions can be. The early panic over Apophis was not a media invention. It came from real orbital calculations that suggested a genuine risk of impact. Those calculations were later corrected, probabilities downgraded, paths refined. But the memory of those first weeks remains. It is a reminder that even with the best telescopes, the best radar, the best simulations, uncertainty always lingers. The asteroid's shape, its spin, its internal structure, even the way sunlight heats and cools its surface can all subtly alter its trajectory over decades. These forces, known as the Yarkovsky effect, are tiny but cumulative. They can bend a path just enough to make the difference between a miss and a hit. When you're dealing with a pass as close as 2029, those tiny effects matter, and that is why the year remains fixed in scientists' minds. The haunting is also psychological. For decades, planetary defence has been an abstract field. Astronomers track tens of thousands of near-Earth objects, logging their sizes and orbits, calculating impact probabilities that almost always fade into insignificance. It is steady, methodical work, often thankless, rarely noticed outside of specialist circles. But Apophis changed that. It took planetary defence from the margins and thrust it into public view. It became the first asteroid in modern history that people could circle on a calendar, the first one to transform risk into appointment. Once that line was crossed, the world changed. Scientists are not used to living with countdowns. They are used to probabilities spread across centuries. Apophis shattered that comfort. Even now, with the danger for 2029 dismissed, the date feels like unfinished business. The asteroid will not strike, but it will pass through a gravitational corridor where even a slight deviation could alter its future path. Scientists call these regions keyholes, narrow windows of space where a flyby bends the orbit just enough to line up a collision years later. The 2029 flyby includes such keyholes. Updated calculations suggest Apophis will miss them, that the 2036 risk is gone, that later encounters are safe. But the principle remains unsettling. A keyhole only a few hundred meters wide can decide the fate of a planet. And when the asteroid passes just tens of thousands of kilometers away, threading space with razor-thin margins, scientists cannot help but remember that the universe does not guarantee perfection. The haunting is not only about impact, but about perception. In 2029, the asteroid will be visible to the naked eye across large swaths of the globe. Billions of people will see it. Billions will feel the instinctive fear that comes with watching a rock that could flatten cities fly between Earth and its satellites. Scientists know the physics. They know it will miss. But they also know that public trust is fragile. If they are wrong, even slightly, the consequences are unimaginable. And even if they are right, the sight alone could trigger waves of panic, superstition and paranoia. Managing the psychology of the event is as challenging as calculating the orbit. The haunting comes not just from the numbers, but from the human response those numbers cannot fully control. 2029 also forces uncomfortable questions about preparedness. What if Apophis were on a collision course? What could we do? Scientists have studied deflection strategies for years. Kinetic impactors that slam into an asteroid to nudge its path. Gravity tractors that hover near it, using their own mass to pull it subtly off course. Nuclear devices that could vaporize or shove it aside. The methods exist in theory, but none of them have been tested on an asteroid this large. None of them are ready to be deployed on short notice. If Apophis were truly coming, if the countdown were not to a flyby but to an impact, humanity would not have the tools to stop it. This knowledge lingers at the edges of scientific thought. The flyby is safe, but the lack of readiness makes it haunt all the same. Some scientists compare the 2029 event to a fire drill. It is not the fire, but it forces us to consider what would happen if the alarm were real. When Apophis streaks across the sky, it will be a global demonstration of what asteroid risk really looks like. It will be a spectacle visible to the entire world, a reminder that cosmic impacts are not just history, but possibility. If the lesson is taken seriously, 2029 could spark real investment in planetary defense, real testing of deflection methods, real international cooperation. But if the lesson is ignored, if the world treats it as a curiosity and then forgets, then the haunting will grow heavier. Because scientists know that luck runs out. Near misses cannot be counted on forever. The haunting is sharpened by irony. The interstellar objects that grab headlines, Oumuamua, Borisov, Atlas, are not the ones that matter. They pass through once and vanish. They stir the imagination but pose no danger. The real threat is from objects like Apophis, ordinary asteroids that orbit the Sun and cross Earth's path again and again. These are not glamorous, they are not mysterious, but they are lethal. The fact that Apophis has a date, that its flyby is scheduled and precise, makes it impossible to ignore. It embodies the truth scientists have tried to communicate for years. The risk is not out there, beyond the stars. It is right here, built into the mechanics of our solar system. Why does 2029 haunt scientists? Because it is the closest we have come to seeing the problem face to face. For years, impacts were something in textbooks and simulations. In 2029, the danger will glide across the sky for everyone to see. It will no longer be a story told to raise awareness. It will be reality, visible and undeniable. Scientists know how rare this is. They know that it is both a gift and a warning. A gift because it offers unparalleled data, a chance to study an asteroid in detail, to test predictions, to refine models. A warning because it shows how vulnerable we are, how little margin separates safety from disaster. The haunting will not end when Apophis departs. The asteroid will remain in the solar system, circling back for future encounters. Its path will continue to be tracked, recalculated, refined. The keyholes of 2036 may be closed, but others in later decades will be analysed. Apophis will never truly leave us. It will be part of planetary defence for the rest of this century and beyond. And every time its orbit brings it near, the memory of 2029 will return. The night when billions looked up and saw how close chaos can come without touching us. The night when scientists watched their calculations play out in real time. knowing that the line between accuracy and catastrophe was vanishingly thin. This is why 2029 still haunts scientists. It is not because they expect impact, it is because they know what it represents. It is the convergence of myth and mathematics, fear and reassurance, spectacle and risk. It is the moment when the abstract becomes tangible, when the serpent in the sky shows its face not in imagination but in reflected sunlight. And once that moment comes, it will never leave us. When scientists describe the 2029 encounter with Apophis, they often use the term flyby. It sounds harmless, almost casual, as if the asteroid were a bird gliding past a window, pausing only to catch a glimpse before continuing on its way. But the more the details are examined, the less comfortable that word becomes. Flyby implies distance. It implies safety. Yet the distance involved in this case is not comforting. It is alarming. On April 13th, 2029, Apophis will skim past Earth at just over 31,000 kilometres above the surface. That is a number that needs context to be understood, because without context it can seem enormous. In reality, it is terrifyingly close. The moon is 12 times farther away. The satellites that beam down television, weather data, and GPS signals orbit higher than the asteroid will pass. Apophis will dip beneath them, cutting through the region of space that humanity uses daily. That region is not empty. It is crowded with technology. Communication satellites, meteorological instruments, military hardware, navigation systems, all hang in a delicate balance at geosynchronous orbit, around 36,000 kilometres above Earth. Apophis will slide under them. To imagine this properly, picture a bullet fired across a busy highway, passing just under the cars and trucks, close enough that drivers could see it streak by if they knew where to look. That is the kind of scale we are dealing with, and this is why the phrase "too close for comfort" is not exaggeration. This is not the vast safe distance of a comet passing millions of kilometres away. This is a rock more than 300 metres wide weaving through the most critical zone of near-Earth space. Scientists know it will miss. They trust the models. But their trust does not eliminate the discomfort. If anything, it heightens it. Because they know how narrow the margin is. They know how many things have to line up precisely for safety to hold. And they know how much we depend on that sliver of space where the asteroid will glide through. There is another detail that makes this flyby unsettling. Apophis will not simply drift past unnoticed. It will be visible to the naked eye from large parts of the world. People in Europe, Africa and Asia will be able to step outside, look up, and see it racing across the sky. No telescope required, no specialised training, no digital filters, just human eyes and reflected sunlight. To see an asteroid of this size, this close, is unprecedented. The event will not be confined to scientists or specialists. It will belong to everyone, and when billions of people can witness it, the psychological weight grows heavier. What had been abstract suddenly becomes real. The asteroid is not a number in a database. It is a bright moving point above their heads, close enough to feel immediate. For those who study planetary defence, this is where the unease lies. It is one thing to reassure the public with statistics when an asteroid will pass 10 million kilometres away. It is another when the asteroid passes within the orbit of satellites, bright enough to be seen by anyone who glances upward. Even the calmest explanations will struggle against what people can see with their own eyes. It will feel close because it is close. The comfort of probabilities collapses when a rock that could destroy a region of Earth glides through space so near that it could almost be mistaken for a slow aircraft. This encounter will also test the resilience of our technology. Satellites in orbit are vulnerable to disruptions from gravitational tides and debris. The asteroid itself is not expected to hit any satellites. Space is still vast even at 31,000 kilometres, but the possibility exists. Even a small fragment knocked loose from Apophis, or a fragment already in orbit disturbed by its passage, could become dangerous. Scientists believe the chance is small, but again, small is not the same as zero. Space agencies will be watching closely, not only to track the asteroid, but to monitor the stability of satellites that provide the backbone of modern life. If a single communication satellite is lost, the economic ripple effect could be enormous. If several are disturbed, the consequences could be global. This adds another layer of discomfort. Even if Earth itself is safe, our technology may not be. Then there is the question of tidal effects. Apophis is large enough that Earth's gravity may alter its structure as it passes. The asteroid is thought to be a rubble pile, a loose aggregation of rock and dust held together more by gravity than by strength. As it dives past Earth, tidal forces could stretch and shift it. Some models suggest parts of its surface may crumble, releasing dust and small fragments. Others suggest it may hold together, altered but intact. Either way, the flyby is not a neutral event for the asteroid itself. Its orbit will change, its internal stresses will be tested, and the uncertainties about how rubble pile asteroids respond to close encounters make this flyby not just a scientific opportunity, but a source of worry. If pieces break off, they could create a swarm of smaller objects, each with its own orbit, each with its own chance of intersecting Earth in the future. The probabilities are low, but again, low is not zero. The emotional discomfort of 2029 also comes from the knowledge of what Apophis could do if it were on a collision course. Scientists have simulated impacts in detail. A rock of this size-striking land would release the energy of tens of thousands of Hiroshima bombs. It would flatten cities, ignite fires, throw dust into the atmosphere, and alter climate patterns. If it struck the ocean, the tsunamis could be hundreds of meters high, racing across basins to crash into coastlines and drown millions. The event would not end civilization, but it would be the most devastating natural disaster in human history. Knowing this, and then watching the asteroid pass within geosynchronous orbit, creates an unavoidable tension. The mind cannot help but imagine what it would look like if the numbers were slightly different. The haunting question is always there. What if? This is why April 13th, 2029 is not just an astronomical event, it is a psychological experiment. Scientists will test their models, observers will collect data, governments will monitor communications and public reaction. But humanity as a whole will experience something unprecedented, the direct, visible awareness of how fragile our safety really is. Most existential threats are invisible. Climate change unfolds gradually. Nuclear risk is hidden in silos and treaties. Pandemics lurk in microscopic biology. But this one will be visible in the sky, a reminder of our vulnerability that requires no explanation. The asteroid itself will be the proof. Some compare this flyby to a close call with traffic. You may never have been hit by a car, but standing on the curb as a truck rushes past within centimetres can make your heart race. The danger is not realised, but the proximity makes it undeniable. Apophis will be like that, but on a planetary scale. Scientists trust the curb. They trust the math that says the asteroid will not deviate. But trust does not eliminate instinct. Instinct responds to what is seen, not what is calculated. And what will be seen in 2029 will be unforgettable. The discomfort also stems from the realization that this is not the last time. Apophis will not vanish into interstellar space. It will remain part of the solar system bound to the sun, destined to return again and again. Each flyby alters its orbit slightly, setting up new encounters in the decades to come. 2029 is not an end. It is a reminder. It is a demonstration of how close these objects can come and how often they will continue to do so. The serpent is not slain. It circles back, patient, waiting for another alignment, another pass, another chance. For scientists, this makes 2029 a pivotal moment. It is both reassurance and warning. Reassurance because the asteroid will miss, proving that their models can predict with astonishing accuracy. Warning because the miss will be so close that it underlines how fragile safety really is. The event is a success of science. and a reminder of nature's indifference. It shows what we can know and what we cannot control. And it leaves us with the knowledge that comfort is temporary, that vigilance must be constant, and that someday another asteroid will not be a flyby. The flyby of 2029 is too close for comfort because it collapses the distance between abstract risk and lived reality. It forces the world to look at the sky and understand that asteroid impacts are not stories of the distant past or far future. They are part of the present, woven into the mechanics of our solar system, and once that understanding is felt, it cannot be forgotten. The comfort of ignorance is gone. What remains is awareness, and awareness is both protection and burden. The flyby of 2029 is often described with precision, down to kilometres and seconds, but hidden within that precision lies a concept that unsettles even the most confident scientists. It is the problem of keyholes. A keyhole, in the language of orbital mechanics, is a small region of space, sometimes only a few hundred metres across, that acts as a gateway to future disaster. If an asteroid passes through such a keyhole during a close approach, the gravitational pull of Earth alters its orbit in just the right way to line it up for a collision years later. These corridors are invisible in the sky, intangible, but they exist, and they transform a near miss into a potential countdown. The idea of a keyhole is unnerving because of how small it is. Imagine an asteroid hundreds of meters across, moving at tens of thousands of kilometers per hour, threading through a region of space smaller than a city block. If it passes through that window, gravity does the rest, setting up a future impact with mathematical inevitability. The asteroid does not need to aim. It does not need intention. The mechanics of the solar system provide the alignment. In this way, a harmless pass can quietly become a loaded gun pointed at Earth decades down the line. Apophis in 2029 carries this problem. When it dives past Earth, it will encounter a series of potential keyholes. Most of them lead to distant future encounters centuries away. One of them once pointed to 2036. If Apophis had passed through that keyhole, the Earth itself would have altered its orbit just enough to guarantee an impact 7 years later. At first, this possibility loomed large. The chance was tiny, but not zero. For years, the 2036 scenario haunted risk tables, forcing scientists to refine their measurements, to narrow uncertainties, to push the probabilities down to negligible levels. Today, those keyholes are ruled out. Apophis will miss them in 2029. But the very fact that they existed, the very fact that the asteroid came close enough to make them relevant, is what lingers in the minds of planetary defense experts. The problem with keyholes is that they are not obvious. You cannot look into the sky and see them. They are calculated through simulations, mapped in abstract diagrams that show lines of probability intersecting with future orbits. To the public, they are invisible and therefore difficult to grasp, but to scientists they are terrifying, because a keyhole is the narrow point where certainty breaks. Before the flyby you can only estimate, after the flyby you know. And in that uncertainty lies the possibility that an asteroid could be harmless today but deadly tomorrow, simply because of where it threads through Earth's gravity field. This problem is not unique to Apophis. Every near-Earth asteroid that passes close enough carries its own lattice of keyholes for future dates. Most are dismissed quickly, probabilities collapsing as more data refines the orbit. But the principle remains. A single close pass can reconfigure the future in ways that are predictable only after the fact. This makes planetary defense a challenge not of raw technology, but of foresight. To act before a keyhole passage, you must trust probabilities. To act after, you may be too late. The case of Apophis demonstrates the stakes clearly. If, in 2029, it were to pass through a keyhole for 2036, the world would have just 7 years to prepare for a certain impact. 7 years is not enough. Deflection strategies require decades of planning, building, and testing. You cannot build a global asteroid defense system on the fly. You cannot develop and launch missions with unproven technology against a fixed deadline and expect certainty. If Apophis were truly on track for 2036, the world would be scrambling with limited tools, hoping against hope that theory would translate into practice. And this is why keyholes are so feared. They compress time. They turn distant risks into urgent crises with little warning. Scientists today are confident that Apophis will not enter any dangerous keyholes in 2029. The data is strong, the orbit refined, the measurements precise. But the lesson remains. It is not just about this asteroid. It is about the fact that keyholes exist at all. The universe is filled with invisible traps, waiting for rocks to stumble into them, setting up impacts decades later. And because they are so small, so precise, they cannot be dismissed until the flyby is over. Until the asteroid passes, you cannot be entirely certain which future path it will take. The unsettling truth is that we often do not know an asteroid's exact trajectory far into the future. The forces that act on these bodies are subtle and varied. The pull of planets, the pressure of sunlight, even the faint drag of thermal radiation can all nudge an orbit by fractions of a millimetre per second. Over years and decades, those nudges accumulate. A slight push today can mean thousands of kilometres of difference tomorrow, and when the difference between safe passage and a keyhole is measured in hundreds of metres, those tiny uncertainties matter. This is what makes keyholes more than just a mathematical curiosity. They are reminders of how fragile predictions can be. The models are robust, but they are not omniscient. They depend on data that is always incomplete, and that gap between knowledge and certainty is where fear resides. For Apophis, the fear is muted today because the data is strong. But in the future, with other asteroids, the same problem will emerge again. Another rock, another close pass, another lattice of keyholes leading to decades ahead. And once again, the world will be forced to ask, what if? In 2029, when Apophis blazes across the sky, the keyholes will be invisible to the billions who watch. People will marvel at the brightness, at the speed, at the spectacle of an asteroid moving faster than any aircraft across the heavens. They will not see the corridors of probability surrounding it. They will not feel the weight of gravitational dynamics shaping futures decades away. But the scientists watching will see it differently. They will know that the asteroid is threading a needle through space, skirting the narrow windows that could have doomed the planet. And they will feel relief when the data confirms it missed them, even if that relief is temporary. Because the problem of keyholes is not solved by one asteroid. It is solved only by preparation. The only way to eliminate the danger is to be able to act before the passage. That means building systems not in reaction to a threat, but in anticipation of it. Telescopes that can detect faint objects decades in advance. Missions that can test deflection methods on harmless targets. International coordination that can turn plans into action when the time comes. Without these, the world remains at the mercy of keyholes. Every near miss becomes a gamble. Every close pass carries a hidden question mark. Apophis may be safe, but the next one may not be. And when that asteroid comes, the world will remember the problem of 2029, the problem of invisible corridors in space that can transform chance into certainty. The serpent will pass, but the lesson will remain, that comfort is conditional, that safety is temporary, and that the universe is filled with narrow windows where the future is decided in silence. When Apophis was first discovered, the number that captured headlines was 3%. That was the estimated chance based on the earliest orbital data that the asteroid could strike Earth on April 13, 2029. For those who live in the world of planetary defense, 3% was shocking, a figure that set alarms ringing because it was orders of magnitude higher than anything normally encountered. For the wider public, the number was terrifying in its simplicity. 3% sounds small when it refers to a chance of rain or a discount at a store. But when it refers to the chance of a city-destroying asteroid impact, it feels unbearable. Yet over time, as more observations were gathered and the number fell to zero, the danger seemed to vanish. The asteroid was reclassified as harmless, a near miss, a spectacle rather than a catastrophe. The odds had gone away, or at least that is what people wanted to believe. The truth is more complicated. The odds never really vanish. They are recalculated, redistributed, moved further into the future. An asteroid does not disappear when its immediate risk is dismissed. It continues to orbit, continues to be influenced by the gravity of planets, continues to shift under the subtle forces of sunlight and thermal radiation. Every close pass with Earth or another planet opens up new branches of probability, new paths through space, new chances that alignments could lead to impact. What was once 3% for 2029 becomes a fraction of a percent for 2036, then perhaps a sliver for 2068, or a possibility centuries later. The odds mutate, but they never collapse entirely. They simply recede into numbers that feel small enough for comfort. This is the essence of the odds we pretend away. Human psychology is poorly equipped to deal with probabilities that involve both low chances and catastrophic consequences. We are trained by daily life to dismiss small percentages as trivial. A 1% chance of rain means you leave the umbrella at home. A 1% chance of winning the lottery means you play anyway. But when the stakes are existential, even a fraction of a percent is not trivial. A 1% chance of a regional or global catastrophe is not something to shrug off. Yet shrugging is exactly what tends to happen, because our instincts treat the number rather than the consequence. Scientists can calculate risk with precision, but the public, and often policymakers, treat anything less than certainty as irrelevant. The Apophis story illustrates this tension clearly. In 2004, when the odds were 3%, the asteroid dominated risk tables. It was given the highest rating ever assigned on the Torino scale, the colour-coded system designed to communicate asteroid hazards. For weeks, it was the most dangerous object in the solar system. When refinements reduced the chance of impact to 0 for 2029, the danger seemed resolved. But at the same time, keyhole scenarios introduced new odds for 2036. The numbers were small, less than 1 in tens of thousands, but they were still numbers. They represented possibilities. And when the chance of catastrophe exists at all, it deserves attention. Yet public focus evaporated. The asteroid slipped into the background again, as if the risk had been erased. Scientists never truly forget those odds. They continue to calculate them, refine them, publish them. They track the uncertainties relentlessly, knowing that each new measurement can narrow the path of the future. But outside those circles, the conversation fades. It is easier to pretend the odds are gone, easier to act as though probability is safety, easier to believe that 0 is the only number worth noticing. This tendency to ignore small odds is not unique to asteroids. It is a recurring feature of human behaviour when facing long-term risks. Climate change was once described in terms of probabilities, with warnings about a 1 in 4 or 1 in 3 chance of severe disruption if nothing was done. Many dismissed those numbers because they were not certain. Pandemics were spoken of as low probability but high consequence events, and until 2020, the odds were ignored. Nuclear war remains a statistical projection of chances that vary with geopolitics, but so long as the number is not 100%, complacency prevails. With asteroids, the pattern repeats. Unless the chance is immediate and obvious, it feels safe to look away. The problem is that asteroids operate on geological timescales, not human ones. Over tens of thousands of years, the chance of a large impact is effectively 100%. The Earth has been struck countless times before, and it will be struck again. The odds are not avoidable, they are inevitable. The only uncertainty is when. But because that when is spread across centuries or millennia, humans translate inevitability into irrelevance. We discount the future, preferring to worry about the near term. Apophis forces us to confront this bias because it puts a date on the calendar. It takes the abstract odds of geological inevitability and attaches them to a specific night, less than a decade away. For a moment, the odds feel real, but once the specific threat is dismissed, the bias returns and the long-term risk is ignored again. Scientists working in planetary defense have tried to reframe the conversation. They argue that it is not about the odds of any one asteroid, but about the collective odds of all near-Earth objects. Tens of thousands have been discovered, many more remain undetected. Even if the chance of Apophis striking in the next century is negligible, the combined chance of something else striking is not. The real number to focus on is the background probability, the statistical certainty that over long periods Earth will be hit, but this argument struggles to gain traction because people prefer stories. Apophis is a story, Atlas is a story, Oumuamua was a story. The collective probability of impact from an anonymous asteroid with no name, no date, no headline, feels like an abstraction again, and abstractions are easy to dismiss. The odds we pretend away are not harmless. They shape policy, or rather, they prevent it. Funding for planetary defense is modest compared to other risks. Budgets for sky surveys, for space telescopes dedicated to finding faint objects, for experimental deflection missions, are small compared to the scale of the threat. Politicians look at the numbers and see comfort. Less than 1%, less than 1 in 10,000. Why spend billions to counter something that seems so unlikely? But the scientists know better. They know that the odds are only low because of short-time horizons. Expand the horizon to the span of human civilization, and the probability converges towards certainty. The serpent will not miss forever. Apophis highlights this contradiction in stark terms. For a brief moment in 2004, the odds of impact were undeniable. The panic that followed showed how seriously the world reacts when the numbers are high enough to break through complacency. But as soon as the probability shrank, the panic evaporated. The asteroid became a curiosity rather than a threat. The lesson should have been that vigilance must continue even when odds are low. Instead, the lesson absorbed by many was that vigilance was unnecessary unless the odds are immediate. That misinterpretation is the real danger. On April 13, 2029, when Apophis passes overhead, the odds will not matter in the traditional sense. The asteroid will miss. The probabilities will collapse into certainty. But the flyby will be a reminder of the broader truth, that impact risk is not about one object, one date, one probability. It is about the inevitability written into the history of the solar system. It is about the fact that we live on a planet that has been struck before and will be struck again. And it is about whether we are willing to treat small odds with the seriousness they deserve, rather than pretending them are away because they are inconvenient to consider. The odds we pretend away are the ones that return to surprise us. They are the silent numbers lurking in the background, ignored until it is too late. Apophis may not strike in 2029 or in 2036 or in 2068, but something else will. The question is not if, but when. And when that day comes, the world will remember that the numbers were always there, waiting, pointing to inevitability. The serpent does not need certainty, it only needs time. For years after the discovery of Apophis, the year 2036 hung over every discussion like a shadow. Once astronomers confirmed that the asteroid would miss Earth in 2029, attention shifted almost immediately to what would happen after. The calculations showed that while the direct threat of impact in that year was gone, the possibility of a dangerous future encounter remained, and one of those future encounters stood out. April 13th, 2036. 7 years after the close approach, a date that seemed far enough away to avoid panic but close enough to be unsettling. The reason for the concern lay in the keyhole problem. As Apophis passed by in 2029, its trajectory would be altered by Earth's gravity. That alteration could, in theory, send it through a tiny corridor of space, a gravitational keyhole, that would line it up for a collision in 2036. The odds were small, fractions of a percent, but they were not zero. And unlike the speculative threats of centuries ahead, This was a possibility within the lifespan of those already alive. Children in school during the 2004 panic could have been parents themselves by the time 2036 arrived. The generational scale of risk was suddenly immediate. The idea of 2036 carried more weight than just numbers. It represented the nightmare scenario of planetary defense, a confirmed impact with only a few years of warning. 7 years is not much time in space terms. Launching a deflection mission requires planning, funding, development, testing, and international coordination. These are processes that typically take decades. If Apophis had been confirmed on a collision path for 2036, humanity would have faced the most urgent engineering challenge in history, with no guarantee of success. It would have been a global scramble, a test not just of technology but of political will. Could nations that struggle to cooperate on climate, energy or war come together to stop a rock from space? Or would hesitation and bureaucracy waste the years, leaving impact as the only outcome? These were the questions that haunted scientists as they ran their simulations. The magnitude of such an impact cannot be overstated. Apophis, at 340 meters across, is not an extinction-level asteroid. It would not wipe out humanity, but it would unleash destruction on a scale the modern world has never seen. If it struck land, the blast radius would cover hundreds of kilometers. Cities would be vaporized. Infrastructure across entire regions would be erased. The death toll would depend on where it landed. Tens of millions if it struck a populated area. Far fewer if it struck wilderness. But either way, the global economy would shudder. Even if the immediate casualties were limited, the long-term consequences would be devastating. Fires, dust clouds and shock waves would ripple outward, and the psychological impact of witnessing such destruction would scar the planet for generations. If Apophis struck the ocean, the devastation would take a different form. Waves hundreds of meters high would radiate outward, striking coastlines thousands of kilometers away. Cities along shores would be drowned. Ports and shipping infrastructure would vanish. Supply chains would collapse. Refugees would flood inland, straining resources and governments. A single impact in the Pacific, Atlantic, or Indian Ocean could transform global civilization overnight. And all of it could stem from a keyhole pass in 2029, a thread of gravity only a few hundred meters wide deciding the fate of billions. This is why 2036 loomed so large. Not because the odds were high, they were never more than a fraction of a percent, but because the consequences were so enormous. The mere possibility was enough to force planetary defense into the spotlight. Agencies began planning scenarios. White papers were written about potential missions. The media latched onto the date, reporting it as though it were destiny rather than probability. And for a time, the world grappled with the reality of what it would mean if a rock like Apophis truly were on its way. By the late 2010s, new observations had effectively ruled out the 2036 impact scenario. Radar data, improved orbital models, and refined measurements of the asteroid's spin and shape all contributed to greater certainty. The keyhole that once pointed toward 2036 was closed. Scientists declared with confidence that Apophis would not strike Earth in that year. The panic faded, the headlines moved on, but the shadow of 2036 never fully disappeared. Because the scenario it represented remains possible, not just for Apophis, but for any asteroid of similar size. The haunting thought is not that Apophis will hit in 2036. It will not. But that one day another asteroid will occupy that role. Another rock will carry a date within human lifetimes, and this time the odds may not be so forgiving. The 2036 scenario also exposed how unprepared humanity truly is. Even as the risk faded, the lessons remained. Deflection methods are still untested at the scale required. International coordination is still fragile. Political will is still reactive rather than proactive. If a real threat emerged with a similar timeline, the scramble would look much the same as imagined during the Apophis scare. And that is what 2036 means, even after being ruled out. It is not just a date on a calendar, It is a symbol of urgency, a reminder that we cannot rely on luck forever. There is also the cultural weight of a second date. 2029 is certain, a flyby etched into calendars. 2036 was the ghost that followed, a what-if that lingered in the public imagination. The pairing of the 2 years created a narrative arc that still shapes how Apophis is discussed. First the panic of discovery, then the relief of the 2029 miss, followed by the renewed anxiety of 2036. Even though the science has moved on, the story remains. People remember that Apophis once carried the threat of impact in 2036, and that memory keeps the asteroid alive in headlines long after its actual risk has diminished. The numbers may say safe, but the myth says danger. For planetary defense experts, 2036 is a case study. It demonstrates the challenges of communication. How do you explain to the public that an asteroid is both safe and dangerous at the same time? That the chance of impact is small but real? That probabilities can change as new data arrives? The 2036 saga showed how difficult it is to balance honesty with reassurance. Too much emphasis on safety, and people dismiss the risk entirely. Too much emphasis on danger, and panic spreads. Finding the middle ground is almost impossible, especially when the stakes involve the survival of millions. Even now, long after the date has been ruled out, 2036 still carries lessons. It shows how fragile certainty is in orbital mechanics. It shows how small gravitational keyholes can dictate futures. It shows how dependent we are on constant observation, on relentless tracking, on never letting the sky slip from our attention. Because if we stop watching, the odds we pretend away will come back to surprise us, and the next date may not be dismissed so easily. What 2036 could mean, then, is not simply an impact scenario that has been avoided. It is a symbol of the larger truth that asteroid risk is not hypothetical. It is real, it is measurable, and it is inevitable given enough time. The serpent missed in 2029, and it will miss in 2036, but the serpent will return in other forms, other rocks, other dates. The real meaning of 2036 is that humanity has been given a preview of the kinds of challenges it will face again, challenges that demand preparation long before the countdown begins. And so the year lingers in the minds of scientists and the public alike. It is not a prophecy, not a certainty, but a memory of what might have been and what might one day be. A glimpse of a future that did not arrive, but could easily arrive under different circumstances. What 2036 means is that the universe will not stop sending rocks across our path, and one day the numbers will not fall to zero. When that happens, the lessons of Apophis will matter more than ever. The fascination with interstellar objects like Atlas is easy to understand. They are strange, new, and rare. They arrive from beyond our solar system, carrying with them an air of mystery. They spark theories about alien technology, about probes disguised as comets, about fragments of other star systems wandering into our own. They dominate headlines because they are exotic. But fascination is not the same as danger. In terms of actual risk to Earth, Atlas and its interstellar cousins are irrelevant. They pass through once and never return. They travel at such speeds that no gravitational pull can capture them. Their trajectories are open-ended, hyperbolic paths that ensure they are gone forever after one brief encounter. They are curiosities. Apophis is not. Apophis matters more than Atlas because it is bound to us. It does not come and go. It circles the sun just as Earth does, crossing our orbit again and again. It is part of the same system, governed by the same gravitational influences, and therefore it will always be nearby. Unlike Atlas, it cannot escape. It is not a visitor, it is a neighbour. And neighbours, no matter how ordinary they seem, are the ones who can cause real trouble. This is the crucial difference. The interstellar objects that generate excitement are too fast and too distant to ever threaten us. They may pass within a fraction of an astronomical unit, close enough to study but never close enough to collide. Apophis, on the other hand, is predictable, measurable, and on a trajectory that brings it directly into Earth's neighbourhood at intervals that can be counted on. It is large enough to matter and close enough to be dangerous. This combination makes it the object of greatest concern, even more so than larger asteroids that stay far away. Because danger is not just about size, it is about orbit. Atlas matters to astronomy. Apophis matters to survival. This distinction is why planetary defence experts focus their attention not on the exotic but on the familiar. Interstellar comets may reveal the chemistry of other star systems. They may provide clues about how planetary systems form, about the distribution of organic molecules in the galaxy, about whether the building blocks of life are common, but they are not threats. They are scientific opportunities. Apophis, by contrast, is a test of our ability to protect ourselves. It is a rehearsal for the kind of impact scenario that will one day happen, whether with Apophis itself or with another near-Earth asteroid like it. The 2020 sign flyby demonstrates this difference with clarity. On that night, Apophis will pass within 31,000 kilometers of Earth. It will shine brighter than many stars visible to the naked eye, moving faster than anything in the sky except satellites. Billions of people will see it, and as they watch, they will be confronted with the reality of asteroid risk. No interstellar visitor has ever come that close, and no interstellar visitor ever will. Atlas may inspire curiosity, but Apophis inspires preparation. The spectacle is not a scientific novelty. It is a reminder of vulnerability. The reason Apophis matters more is also historical. Earth has been struck by asteroids countless times in the past. The scars are carved into its surface. The Barringer crater in Arizona, the Tunguska blast zone in Siberia, the Chicxulub crater in Mexico. Every one of these events was caused by an object that originated within our solar system, not beyond it. There is no evidence that interstellar comets or asteroids have ever struck Earth in recorded history. All the real impacts, all the devastation, have come from objects like Apophis. Rocks perturbed from the asteroid belt, drifting inward, crossing Earth's orbit again and again until one day the geometry aligns. If the past is a guide, it is the local asteroids, not the interstellar wanderers, that shape the fate of planets. Scientists understand this distinction, but the public often does not. People are drawn to stories that feel extraordinary. Atlas feels extraordinary. Apophis feels ordinary by comparison, and yet its ordinariness is what makes it dangerous. A rock hundreds of meters across, on an orbit that brings it within the range of satellites, is not dramatic science fiction. It is statistical inevitability. This is why planetary defense experts grow frustrated when interstellar visitors capture headlines while Apophis struggles to remain in the news. The priorities are inverted. The danger lies in the predictable, not the exotic. Apophis also matters more because it exposes weaknesses in our preparedness. If Atlas were a threat, which it is not, there would be nothing we could do because it moves too fast and too far away to intercept. But its speed and distance also guarantee safety. Apophis moves at speeds and along paths that are within our reach. In theory, we could intercept it. We could send missions to deflect it if it were on a collision course. It is the type of object for which planetary defense is designed. And yet, as of today, we are still not fully ready. We have tested some technologies, like the DART mission, that successfully altered the orbit of a small asteroid in 2022. But we have never tested those methods on an object the size of Apophis. We have never attempted them on a timeline measured in years rather than decades. The fact that Apophis is real, close, and potentially threatening makes these gaps in preparedness glaring. In 2029, when Apophis streaks past, the contrast will be impossible to ignore. The interstellar objects that once drew our attention will seem trivial in comparison. The rock in the sky that everyone can see will not be a visitor from another star, but a local neighbour reminding us of our place in the solar system. It will not matter how unusual Atlas's chemistry was, or how strange Oumuamua's shape appeared. What will matter is that a 340-metre asteroid just passed closer than our satellites, and we had no way to stop it if its path had been slightly different. That reality will be the lesson. Apophis matters more than Atlas because it changes how we think about time. Interstellar objects remind us of the vastness of the galaxy, of the distances between stars, of the scale of cosmic wanderers. But Apophis reminds us of the immediacy of risk. It has dates attached. 2029, 2036, 2068. The story of Apophis is not written across millions of years. It is written across decades, the timescale of human lives. This transforms the conversation from the abstract to the urgent. It forces us to see asteroid impacts not as ancient history or distant future, but as events that can unfold within our own experience. The asteroid also matters more because of its symbolism: Atlas, Oumuamua, Borisov. These names inspire wonder, but not fear. They are curiosities, postcards from other systems. Apophis carries the weight of mythology. It is the serpent of chaos, the enemy of the sun, the eternal threat of destruction. The name amplifies its reality. It is not just a number in a catalogue. It is a reminder of humanity's vulnerability to the sky. When billions of people look up and see it, they will not think of chemistry or spectroscopy. They will think of danger. And that perception, however shaped by myth, will align more closely with reality than fascination with distant wanderers ever has. This is why scientists keep emphasizing Apophis when the world is distracted by Atlas. The real risk lies not in the alien, but in the ordinary. Not in the strange, but in the predictable. Not in the distant, but in the near. Apophis embodies that truth. It is a warning written in stone and orbit. It matters more because it is a rehearsal for the inevitable. The serpent will pass in 2029, but it will not be the last. Others will follow. And whether we are ready when they come depends on whether we learn the right lessons from Apophis, or whether we allow ourselves to be distracted by the allure of the extraordinary. The threat from space has always been difficult for humans to imagine because most of it is invisible. Cosmic rays bombard us, gamma bursts flicker far away, supernovae explode in distant galaxies. These are powerful events, but they are either too far or too intangible to inspire immediate fear. An asteroid, however, is different. It is a bullet we can see, track, measure, and predict. Unlike invisible cosmic threats, asteroids can be followed like predators on a map, their positions plotted, their futures calculated with extraordinary accuracy. Apophis is the perfect example of this. It is a cosmic bullet whose trajectory we know, a projectile moving silently through space on a path that brings it frighteningly close to Earth. To call Apophis a bullet is not metaphorical exaggeration. At more than 300 meters across and moving at roughly 30 kilometers per second relative to Earth, it carries energy equivalent to tens of thousands of nuclear weapons. If it were to strike, it would unleash devastation across continents. That energy is not speculative. It is physics. The kinetic energy of a mass multiplied by the square of its velocity leaves no room for debate. Apophis is a loaded round in the solar system's chamber, and its orbit has already been aimed in our direction. The only difference between impact and safety is whether the barrel aligns perfectly or glances by. What makes Apophis particularly unsettling is that we can measure it so precisely. Radar observations from the now-collapsed Arecibo Observatory and the Goldstone Solar System radar have mapped its size and shape. It is not a smooth sphere, but an elongated, irregular rock. Its surface rough, its spin complex. These measurements allow scientists to model not only its orbit, but also the way sunlight heats and re-emits from its surface. A subtle effect that can alter its trajectory over decades. Known as the Yarkovsky effect, this thermal push is tiny but cumulative. nudging the asteroid in ways that matter when keyholes only hundreds of meters wide separate safety from disaster. Apophis is a cosmic bullet, but one whose path is influenced by forces as delicate as the way sunlight warms one side more than the other. This ability to measure so precisely is both a comfort and a curse. It allows us to rule out impacts in 2029 and beyond, to refine probabilities until they shrink to negligible values. But it also forces us to face the reality that near misses are only near misses. The fact that Apophis can be measured so clearly means that we can never dismiss it as unknown. It is not the vague threat of something out there, unseen. It is a specific, numbered, named object with a future that is tied to ours, and because it can be measured, it cannot be ignored. Other risks like earthquakes or volcanic eruptions strike without warning. Asteroids give us warning, but that warning is a double-edged sword. It provides time to prepare, but it also provides time to worry. Knowing that Apophis will pass within 31,000 kilometers on a specific night in April 2029 creates a sense of inevitability. There is nothing we can do to stop that flyby. No deflection mission could alter its path in time. All we can do is watch, measure, and wait. It is a countdown that inspires both confidence in science and discomfort in human instinct. The bullet is coming. It will miss, but it will not miss by much. The phrase cosmic bullet also captures the randomness of asteroid impacts. Earth has been struck many times before, but the timing and location are always uncertain. The craters dotting the surface of our planet testify to past collisions, each one the scar of a bullet that did not miss. The Tunguska event in 1908 was caused by an object less than a quarter the size of Apophis, yet it flattened 2,000 square kilometers of forest. The Chelyabinsk meteor in 2013, only 20 meters across, still injured more than 1,000 people when it exploded in the atmosphere. Apophis is an order of magnitude larger. To compare it with those past events is to see how fragile our luck has been. The bullets that have struck us so far were smaller. Apophis reminds us that larger ones exist and that they can be tracked, measured, and timed. The ability to measure Apophis also reveals our vulnerability in another way. By knowing its orbit so well, scientists can predict not just the 2029 flyby, but its future passes decades and centuries into the future. The predictions are reassuring in the short term. No impact in 2029, none in 2036, none in 2068. But they also underline the long-term inevitability of impact from something, if not Apophis, then another asteroid like it. The solar system is full of cosmic bullets. Most miss, but some will not. Measuring Apophis so carefully is like watching a bullet pass inches from your head. You may be safe this time, but you know the gun is still loaded and there will be other shots. What makes Apophis unique among cosmic bullets is that it will be visible. On the night of April 13th, 2029, it will shine in the sky, brighter than many stars, moving across the heavens faster than the naked eye can usually perceive. This visibility transforms it from a scientific object into a human experience. Billions will see it. Billions will feel the instinctive fear that comes with watching a destructive force glide so close to Earth. It is one thing to calculate risk in equations. It is another to witness it with your own eyes. The bullet will pass overhead, silent, unstoppable, reminding everyone who sees it that our world is not isolated. It lives in a cosmic shooting gallery. This visibility also carries symbolic weight. For the first time in human history, people will be able to point at a specific asteroid and know that it has been tracked, calculated, and predicted to a degree that rivals our best engineering. The fact that we can measure it so precisely demonstrates the power of science. But the fact that it exists at all demonstrates the indifference of the universe. The bullet cares nothing for our calculations. It moves on its path regardless. The flyby will prove both our capability to measure and our inability to control. The ability to measure Apophis also sharpens the question of preparedness. If we can track it this precisely, Why can we not stop it if it were truly on a collision course? The answer lies in technology, politics, and time. The methods of deflection, kinetic impactors, gravity tractors, nuclear options, exist in theory, but they require decades of lead time to implement safely. For Apophis in 2029, there is no need and no possibility. It will miss. But what if the numbers had been slightly different? What if the bullet had been aimed directly at Earth? Would we have been able to act in time? Most experts admit that the answer is no. The measurement capability is far ahead of the deflection capability. We can see the bullet. We cannot yet dodge it. This imbalance is what makes Apophis matter so much. It is a wake-up call in the form of a precise trajectory. It is proof that we can track asteroids with extraordinary accuracy, but also proof that knowing is not the same as being ready. The serpent will glide past us, the bullet will miss, but the lesson is not about this pass. It is about the next one, and the next, because sooner or later one of these bullets will not miss, and when that happens, measurement alone will not save us. Preparation will. Apophis is a cosmic bullet we can measure, but the measurement should not lull us into complacency. The comfort of precise numbers can disguise the discomfort of inevitability. The asteroid is not unique. It is one of many. What makes it special is that its path brings it close enough to remind us, close enough to strip away the illusion that we are safe by default. In 2029, the world will watch the bullet pass. It will marvel, it will worry, it will speculate, but the real question is whether it will act. Because measuring the bullet is only the first step. The harder step is ensuring that, next time, we can deflect it before it ever reaches us. When Apophis comes close to Earth in 2029, the difference between missing and hitting will be measured not in millions of kilometers, not even in thousands, but in tens of thousands. To the human mind, that might still sound like a comfortable cushion, a distance that feels vast enough to guarantee safety. But in the scales of the solar system, and in the physics of impacts, that difference is razor thin. A near miss and a collision are separated by margins that are both terrifyingly small and deeply consequential. This is what makes the encounter with Apophis so sobering. It shows that the gulf between survival and catastrophe can be narrower than we would like to believe. Missing by 31,000 kilometers sounds reassuring when compared to the size of the Earth itself, which is over 12,000 kilometers in diameter. But put in perspective, it is sobering. If you shrank the Earth to the size of a basketball, Apophis in 2029 would pass by closer than the width of a finger. That is not a comfortable margin. It is a reminder that the universe does not guarantee safety with wide buffers. It offers us close calls, grazes, and narrow escapes. The asteroid will not strike, but the geometry of its path underlines how thin the boundary really is. The difference between missing and hitting also lies in consequences. A miss means a spectacle. Billions of people will watch the sky, marvel at a moving point of light brighter than many stars, and then return to their lives. A hit, however, would redefine history. A rock 340 meters across would not merely dent the Earth's surface, it would devastate it. Whether striking land or ocean, it would release energy many times greater than the largest nuclear weapons ever built. It would flatten cities, ignite fires, cause shockwaves, and unleash tsunamis. Entire regions would be altered in seconds. Global systems of trade, communication, and politics would be thrown into chaos. Missing means life continues. Hitting means the world becomes unrecognizable overnight. The scale of this contrast makes the fine margin of safety even harder to comprehend. This thin line between miss and hit is why the keyhole problem is so feared. A keyhole only a few hundred meters wide can determine whether an asteroid that misses once comes back to hit later. For Apophis, 2029 will not result in an impact, but the idea that the difference could hinge on such a narrow corridor in space is what unsettles scientists. It means that missing once is not the same as safety forever. It means that the difference between survival and destruction is not measured only in kilometers, but in the invisible threads of gravity that guide these objects across decades. The psychological weight of this difference cannot be overstated. Humans are not well suited to imagining near misses. Our instincts interpret survival as safety. If the asteroid passes us by, we breathe a sigh of relief and consider the danger over. But in reality, the difference between missing and hitting is not comfort, it is chance. The physics of Apophis's orbit place it close to Earth, close enough that small shifts could mean a different outcome in another timeline. The asteroid will miss in hours, but the possibility that it could have been otherwise lingers. And that lingering possibility is what haunts those who think about planetary defense. The difference between missing and hitting also exposes the fragility of human preparedness. If Apophis were on a collision path in 2029, there would be nothing we could do. We would have too little time to act. Even with years of warning, the technology to deflect or destroy an asteroid of this size remains untested. The DART mission proved that a kinetic impactor can alter the orbit of a small asteroid, but Apophis is far larger. The energy required to shift its path would be orders of magnitude greater. A deflection would need to be planned decades in advance, not years. The fact that Apophis is going to miss highlights this gap. We are safe this time, but if it was slightly closer, slightly more aligned, we would face disaster without the tools to stop it. And this is perhaps the most unsettling part of the difference between missing and hitting. It is not that the asteroid is narrowly passing us by, but that our survival depends entirely on luck. The asteroid's orbit is not under our control. It is a consequence of gravitational interactions that stretch back millions of years. Its current path is the result of chance encounters with other bodies, of tiny nudges from sunlight, of the chaotic dance of the solar system. That those chance events happen to produce a near miss rather than a direct hit in 2026 is luck, nothing more. It is not the result of preparation, not the result of planetary defense. It is fortune, and relying on fortune is not a strategy. The difference between missing and hitting also extends to perception. In 2029, people will watch Apophis pass and marvel at the sight. Many will interpret the miss as proof that asteroid fears are exaggerated. They will say, "See, it passed us by. There was nothing to worry about." But those who understand the science will know that the miss is not reassurance. It is a warning. It is a demonstration of how close the bullets of the solar system already come to our planet. A hit is not hypothetical. It is inevitable given enough time. The miss is temporary. The danger is permanent. Scientists often point out that asteroid impacts are not like earthquakes or hurricanes, where predicting exact events is nearly impossible. Asteroids follow orbits that can be measured and modelled. The difference between missing and hitting can, in many cases, be calculated decades in advance. This is what makes the problem so unique. We can know when the bullet is coming. We can measure its trajectory. We can prepare in theory, but the preparation is useless if it is not acted upon. The miss in 2029 will be a chance to show that we can predict with extraordinary precision. Whether it also becomes a chance to prepare for the next threat is another question. In many ways, the difference between missing and hitting comes down to perspective. On one hand, a miss means we are safe, at least for now. On the other, a miss means we have been reminded of how narrow the margins are, how fragile our place in the solar system is, how little separates life as usual from global catastrophe. Both perspectives are true. Both must be held at once. The difficulty lies in convincing humanity to see beyond the comfort of the miss and to act as though the hit is still inevitable someday. Apophis embodies this duality. Its flyby will be a triumph of science, a spectacular event predicted years in advance with uncanny accuracy. But it will also be a reminder of vulnerability. The asteroid could have been on a slightly different path. It could have been an impactor instead of a passerby. The difference between those scenarios is almost nothing in astronomical terms, yet everything in human terms. One leaves us watching the sky. The other leaves us scrambling for survival. That is the razor's edge on which planetary defense exists. When Apophis glides by in 2029, it will not strike Earth. It will miss by what the numbers say is a comfortable margin, but those same numbers remind us that comfort is relative, that safety is temporary, that the line between missing and hitting is thin enough to demand constant vigilance. And that is why the flyby will matter long after the asteroid is gone. It is not just a near miss. It is a demonstration of the difference between survival and disaster, a difference measured in kilometers and seconds, a difference that will one day determine the fate of millions. When we speak about cosmic distances, the numbers almost lose meaning. 1,000,000 kilometers sounds vast, 100,000 sounds enormous, even 30,000 seems almost unreachable. The human mind is trained by daily life, where distances are measured in meters, kilometers at most, not in planetary scales. So when scientists say that Apophis will pass within 31,000 kilometers of Earth in 2029, the number feels both abstract and oddly safe. It feels like a margin that separates us comfortably from danger. Yet the reality is that this distance is uncomfortably close, closer than the satellites we depend on, closer than many people can truly comprehend. Which leads to the question that has lingered since the asteroid was first discovered: how close is too close? The answer begins with context. The Moon, which feels near to us, hangs at an average distance of 384,000 kilometers. Every human who has ever looked at the night sky has seen it there, looming large and familiar. Apophis will come 12 times closer. The International Space Station, where astronauts circle Earth, orbits at just over 400 kilometers. Apophis will not skim that close, but it will cut through the region where satellites hold their place in geosynchronous orbit, about 36,000 kilometers up. This is the quiet belt of machines that keep the world connected. GPS signals, satellite television, weather tracking, military communication, all of it depends on those devices floating high above the surface. Apophis will pass beneath them. For scientists, this is already too close for comfort. Not because the asteroid will strike the satellites, it is unlikely given the vastness of space even in that orbit, but because the passage demonstrates how vulnerable the infrastructure of human civilization really is. The difference between Apophis's trajectory and the satellites we rely on is measured not in millions, but in thousands of kilometers. That is a thin line for comfort when dealing with a rock that could level entire regions of Earth. The asteroid will miss, yes, but the fact that it slices through our technological lifeline is enough to expose the fragility of what we take for granted. Too close is also a matter of perception. The human eye will be able to see Apophis during its 2029 flyby. It will not require telescopes, not even binoculars. A person standing in parts of Europe, Africa or Asia will be able to step outside, look up, and see the asteroid gliding across the sky, brighter than many stars. This is unprecedented. Never before in modern history has an asteroid of this size come so close and been so visible. The fact that it can be seen with naked eyes is not just a novelty. It is a visceral reminder of vulnerability. People will not need to be told it is close. They will feel it because they can watch it moving above them, a rock large enough to destroy cities racing silently by. Too close is not only a question of physics, it is a question of instinct. An instinct will not be soothed by statistics. When scientists say Apophis will miss, they speak with confidence grounded in calculations. Their models are robust, their data refined. But confidence in prediction is not the same as comfort in instinct. To say the asteroid will pass within 31,000 kilometers is to say that Earth and disaster are separated by a margin, small enough that even minor deviations could make the difference. This is where the question of how close is too close becomes more than just a scientific exercise. It becomes psychological, political, even cultural. People do not easily accept safety when danger can be seen with the naked eye. The idea of too close also depends on what we are willing to accept as risk. Scientists can point to probabilities saying that the chance of impact in 2029 is 0. But what about the keyholes that could lead to future encounters? What about the uncertainties introduced by the Joukowsky effect, where heat from the sun subtly alters the asteroid's path over years? What about fragments that could break off during the flyby, creating new hazards? The model suggests none of these scenarios will create danger in 2029, but the fact that they are considered at all points to the deeper truth. Proximity multiplies uncertainty. An asteroid that passes millions of kilometers away leaves no doubt. An asteroid that passes within tens of thousands raises questions, even if the answers are reassuring. Too close is also about history. The Earth has been struck before, and it will be struck again. The craters on its surface, from Arizona to Mexico to Siberia, are reminders of what happens when rocks from space align with our orbit. The Tunguska event of 1908, caused by an object much smaller than Apophis, levelled 2,000 square kilometres of forest. The Chelyabinsk event of 2013, caused by a rock only 20 metres across, still injured more than 1,000 people when it exploded in the atmosphere. These were not near misses, they were hits, and they show how little margin there really is. Apophis will pass much closer than either of those objects did before striking. It will miss, but the knowledge that it could have been otherwise is what makes the distance feel insufficient. Too close is defined not just by physics, but by memory. The question of how close is too close also ties into preparedness. If Apophis were on a collision course, we would not have the tools to stop it. We could not scramble in the years before 2029 to deflect or destroy it. We would have no choice but to endure the impact. This is the real definition of too close. It is not simply about physical distance. It is about how much time we have to respond. Too close is any approach that leaves us unprepared to act. And by that measure, 2029 is already too close. Because if the asteroid were on target, there would be nothing we could do. We would be left to face the consequences of luck rather than preparation. How close is too close? The answer depends on what is at stake. For a satellite operator, too close may mean anything that passes through geosynchronous orbit. For a planetary defense scientist, too close may mean any object that enters within a few lunar distances, because those are the ones that matter most for long-term probability. For the public, too close may simply mean anything that can be seen with the naked eye, because visibility translates directly into fear. Each perspective defines the threshold differently, but they all circle the same truth. Safety is not absolute, it is relative. And the closer an asteroid comes, the more fragile that safety becomes. In 2029, when Apophis streaks across the sky, the world will have to confront this question directly. People will ask why the asteroid came so close. They will ask why nothing was done. They will ask what would happen if the predictions were wrong. And scientists will answer with confidence, explaining the calculations, the data, the models. But underneath those explanations will linger the same unease that has haunted every discussion of Apophis since its discovery. Because the real answer to the question is simple. How close is too close? Closer than this. Closer than 31,000 kilometers. Closer than the satellites we depend on. Closer than the comfort of a number that feels safe but is not. Apophis will miss, but the encounter will leave us with an unavoidable awareness that in the vastness of space, safety is measured not in absolutes but in margins. That margins can be thin, and that one day one asteroid will cross the invisible line where too close becomes impact. When the possibility of Apophis colliding with Earth was first announced in 2004, the response from governments, institutions and the public revealed something more than fear. It revealed how the world handles information about existential threats, and how quickly reassurance and denial can compete with one another. The asteroid itself was never the only story. The other story was how humanity reacted when told that a specific date might bring a disaster, unlike anything we had experienced in modern history. That reaction remains one of the most important parts of the Apophis saga, because it shows what will happen when, not if, another asteroid is discovered with a trajectory that does not miss. The first reaction was silence. Scientists in the discovery teams processed the data quietly, ran their orbital calculations, and realized that the numbers pointed to something extraordinary. There was a chance, small but real, that Earth could be struck in 2029. At first, the data circulated only in technical circles, tucked into reports and academic discussions. But numbers like that cannot stay hidden. As more telescopes confirmed the orbit, the probabilities became harder to downplay. When the information reached the press, silence gave way to headlines, and once the story spread, the world had to decide how to respond. In the United States, NASA played a balancing act. On one hand, it had a duty to present the facts. On the other, it had a responsibility not to incite panic. The agency issued carefully worded statements, explaining that there was a small chance of impact, but that the probability would likely shrink with further observations. The emphasis was on calm, on the long process of refinement, on the idea that science takes time. Yet behind the calm, officials knew that this was a serious scenario. No asteroid had ever carried such high odds before. The public relations problem was as complex as the orbital mechanics. How do you tell billions of people that there is a 1 in 30 chance that an asteroid will destroy a city, or worse, without causing chaos? Other governments responded in different ways. Some downplayed the story entirely, treating it as another piece of distant astronomical trivia. Others echoed NASA's cautious optimism, repeating that the chance of impact was low. A few used the moment to push for more funding for asteroid surveys, recognizing that the only way to reduce uncertainty was to gather more data. But none declared a state of urgency. None mobilized resources at the scale the risk might have warranted. The prevailing approach was reassurance, not preparation. This pattern was not new. Humans are wired to respond to immediate dangers, not distant probabilities. A storm on the horizon triggers evacuation. An earthquake demands immediate response. But an asteroid decades away, with odds that sound both small and terrifying, triggers something different. Denial. The threat is either exaggerated or ignored, depending on which narrative is easier to accept. Reassurance becomes the public message. Denial becomes the private comfort. Together, they form a coping mechanism that allows society to move forward without confronting the full weight of the risk. The media reflected this duality. At first, headlines screamed about a possible asteroid impact, framing Apophis as a doomsday rock hurtling toward Earth. The drama was irresistible. But as scientists issued clarifications and the odds began to shrink, the tone shifted. Suddenly, the asteroid was described as a close call, a fascinating spectacle, a reminder of how clever science can be at predicting the cosmos. The panic gave way to curiosity. By the time the risk for 2029 was downgraded to 0, most coverage had already softened. Apophis became a story of reassurance, proof that astronomers were watching the skies, not a story of danger that required immediate global action. This shift was not accidental. It was shaped by the institutions that control information. Governments and scientific agencies understood that fear could spiral out of control. They remembered how public panic had erupted during other global threats, from pandemics to nuclear standoffs. They wanted to prevent chaos. And so the emphasis was placed on calm explanation, on patient science, on reassurance. The problem, of course, is that reassurance without preparation is a form of denial. Telling people not to worry without addressing the real gaps in planetary defense leaves the world no safer than before. The asteroid may miss, but the next one may not. Reassurance without readiness is comfort borrowed from luck. Apophis also revealed the unevenness of global response. Wealthy nations with space agencies had the ability to measure, calculate, and track. Poorer nations did not, yet the consequences of impact would not respect borders. An asteroid hitting one hemisphere would affect the climate, economy, and stability of the other. The risk was global, but the information and resources were not. For many countries, denial was not even a choice. It was a necessity born from having no role in the monitoring or mitigation of the threat. They could only wait and trust that someone else, somewhere else would handle it. The years that followed showed how fragile the balance between reassurance and denial really was. When the possibility of a 2036 impact remained on the table, the story resurfaced. Once again, agencies insisted the odds were small. Once again, the media reported briefly, then moved on. Once again, the public absorbed the story with a mixture of fascination and dismissal. By the time new observations ruled out 2036 entirely, Apophis had become background noise. Most people assumed the danger was over. Few realised that planetary defence had only just begun to take shape as a serious field. The denial had worked. The story was over, even if the underlying risk was not. The global response to Apophis matters because it sets the precedent for the future. When another asteroid is discovered with a real chance of impact, the same pattern is likely to repeat. At first, there will be silence while scientists confirm the data. Then there will be alarm as probabilities are announced. Governments will issue carefully measured statements. Media will oscillate between panic and curiosity. And eventually the dominant narrative will settle into reassurance, whether justified or not. Denial will creep in as soon as it becomes convenient. The question is whether this cycle will be broken by real preparation, or whether humanity will continue to gamble on luck. Reassurance is not inherently bad. It prevents panic, preserves order, and allows time for careful study. But it is dangerous when it replaces action. Denial, too, is not surprising. It is a natural psychological defense against threats that feel overwhelming. But denial is fatal when it prevents preparation. Together, reassurance and denial form a fragile shield against fear. They calm the mind, but they do not protect the planet. Only action can do that. And Apophis showed that action was still minimal, still fragmented, still far behind where it needed to be. The global response to Apophis is a mirror of humanity itself. We are a species capable of extraordinary calculation, able to measure the path of a rock across millions of kilometers with stunning accuracy. But we are also a species that struggles to act on risks until they are unavoidable. We measure the bullet, but we hesitate to build the armor. We watch the serpent, but we convince ourselves it will not strike. In 2029, when billions watch Apophis glide across the sky, that duality will be on full display again. Some will marvel at the beauty. Some will feel a chill of fear. Governments will reassure. Skeptics will deny. And the asteroid will pass, indifferent to both. What the global response shows more than anything is that the real danger is not just in the sky. It is in our own inability to confront uncomfortable truths. Apophis will miss in 2029. The odds for 2036 are gone. But the universe has no shortage of rocks. Another one will come. When it does, the choice will be the same: reassurance, denial, or preparation. The past suggests which path we are most likely to take. The question is whether luck will continue to protect us long enough for that habit to change. When Apophis was discovered and the first alarming probabilities were released, the asteroid itself was not the only problem scientists faced. The numbers were clear enough for anyone with access to the data to see. The real problem was how to communicate those numbers. Saying that a rock several hundred meters across might strike Earth in 2029 was not like reporting the chance of rain or the odds of a sporting event. This was not information that could remain confined to academic journals or tucked away in technical bulletins. Once it reached the public, it became something else entirely. It became political. The way information was shared, the way probabilities were explained, and the way reassurances were delivered were all filtered through the machinery of governments, institutions, and media. And in that machinery, the science of asteroid risk collided with the politics of communication. The challenge was not new. Governments have always struggled with how to communicate threats that involve probabilities rather than certainties. Nuclear risk, climate projections, pandemic warnings, all of them share the same problem. Too much emphasis on danger risks sparking panic. Too much emphasis on reassurance risks encouraging complacency. striking the balance is difficult enough when the stakes are manageable. When the stakes are planetary survival, the challenge becomes nearly impossible. Apophis showed this in real time. The numbers were there. The difficulty was deciding how to tell the world. At NASA, the Torino scale was created to simplify asteroid threats into a system of colour-coded categories, much like the Richter scale does for earthquakes. 0 meant no danger, 10 meant global catastrophe. In theory, it was a clear tool to communicate risk. In practice, it became a political minefield. Apophis was given a rating of 4, the highest ever assigned at the time. That number, combined with headlines, carried weight. It meant a chance of impact capable of regional devastation. But to the public, the difference between a 4 and a 10 was unclear. All they saw was danger. To officials, the scale that was supposed to clarify instead magnified the problem. Communicating the nuance, that a 4 did not mean certain impact but only a probability, proved harder than expected. Other governments faced the same dilemma. Should they echo the concern? Should they soften it? Should they stay silent until more was known? Every choice carried consequences. Saying too much risked public unrest. Saying too little risked accusations of a cover-up. In democratic societies, the media amplified the problem. Headlines demanded clarity where science could only offer probabilities. In more controlled societies, the issue was buried, but that too created suspicion. Once the story was global, no government could avoid taking position. And once positions were taken, the conversation shifted from science to politics. The politics of risk communication often come down to trust. Does the public trust the agencies delivering the information? Do politicians trust the scientists advising them? With Apophis, trust was fragile. For decades, the idea of an asteroid impact had been relegated to science fiction or distant history. Few outside of specialized circles took it seriously. When the numbers suddenly suggested a real threat within a specific time frame, it felt like a shock. Trust was tested, and once trust is strained, every word of communication becomes loaded. A cautious explanation sounds like downplaying. A warning sounds like exaggeration. A prediction sounds like prophecy. Every phrase becomes vulnerable to misinterpretation. The political stakes grew because asteroid risk is not confined to one nation. If Apophis had struck, it would not have mattered which hemisphere it landed in. The consequences would have been global. But the responsibility for communication fell on a few agencies with the tools to measure it. NASA in the United States, ESA in Europe, a handful of observatories in Russia and Japan. These institutions had to speak not only to their own citizens, but to the entire planet. Their words carried weight far beyond their borders, and that weight turned every statement into a political act. To say, the risk is low, was to influence international calm. To say, the risk is real, was to potentially destabilize markets, politics, and public order. The asteroid itself was silent. The human response was shaped by the politics of words. The debate over how to frame the risk became as intense as the science of calculating it. Should probabilities be given as raw numbers? Should they be simplified into categories? Should officials stress the worst-case scenario to prepare for it, or stress the most likely outcome to avoid panic? Each approach had drawbacks. Raw numbers could confuse the public. Categories could oversimplify. Emphasizing danger could undermine confidence. Emphasizing safety could discourage preparation. The politics of risk communication is always about choosing which drawback is tolerable, and with Apophis, the drawback chosen was reassurance. The probability was reported, but the emphasis was always on the idea that it would shrink with time, and it did. Which meant that, in hindsight, the strategy seemed correct. But the comfort of hindsight does not erase the risks of the moment. The politics of communication also extended to funding. When Apophis made headlines, calls for more investment in asteroid detection and planetary defense grew louder. Politicians faced a choice: admit the threat and allocate money, or downplay the danger and save resources for other issues. The decision often depended not on the science, but on the politics of the moment. In some cases, leaders seized the opportunity to demonstrate foresight, framing funding as protection against catastrophe. In others, they minimized the story to avoid committing money to something the public might dismiss as science fiction. The asteroid was real, the funding was political, and the way the risk was communicated shaped the outcome. Another layer of complexity came from international coordination. If a future asteroid were confirmed to be on a collision course, who would decide how to respond? Who would launch the deflection mission? Who would pay for it? Who would take responsibility if something went wrong? These questions were already being debated during the Apophis scare, even though the immediate risk was small. But none had clear answers. Communication across nations was uneven. Some wanted transparency, others wanted control, some wanted public engagement, others wanted secrecy. The politics of risk communication are not just about words, they are about power, and Apophis showed that power was unevenly distributed. There was also the problem of conspiracy. Whenever global threats are discussed, suspicion follows. Some people believed governments were hiding the true risk. Others believed scientists were exaggerating it for funding. Conspiracies thrive in the gaps between reassurance and denial, feeding on uncertainty. With Apophis, these narratives circulated quickly. Even when probabilities were reduced to zero, some remained convinced that the danger was being covered up. This reveals another dimension of the politics of communication. No matter how carefully the message is crafted, not everyone will believe it. And disbelief can spread faster than science. The politics of risk communication ultimately reveal more about humanity than about asteroids. Apophis was a natural object, indifferent and predictable. The danger came not only from its orbit, but from our inability to agree on how to talk about it. The asteroid tested not just our telescopes, but our institutions. It showed how fragile trust is, how easily reassurance slides into denial, and how communication becomes political the moment survival is at stake. In 2029, when Apophis passes by and billions see it with their own eyes, the politics of communication will be tested again. Agencies will issue statements. Governments will choose their words carefully. Some will frame it as a triumph of science. Some will downplay the spectacle to prevent panic. Some will seize the moment to call for more funding. Some will ignore it entirely. And once again, reassurance and denial will compete for dominance. The asteroid will glide past indifferent, leaving humanity to wrestle with its own words. What Apophis demonstrates is that survival is not only a matter of physics, it is also a matter of communication. The way risks are explained determines how societies respond. The way probabilities are framed determines whether action is taken. The asteroid may be silent, but the politics of communication are loud, and they will shape whether humanity faces the next real threat with preparation or with the fragile comfort of words. When the discovery of Apophis first made its way into headlines, one of the immediate questions that followed the fear was deceptively simple. What could be done? The idea of a massive rock colliding with Earth is horrifying, but the second horror, the quieter one, is realizing how little humanity can actually do to stop it. This is where the concept of preparedness collides with the illusion of control. We like to imagine that in the modern age, with satellites orbiting our planet and rovers crawling across Mars, with rockets powerful enough to deliver payloads across the solar system, we must have a plan for something as fundamental as an asteroid strike. Yet Apophis revealed the truth. Preparedness is limited, fragmented, and often exaggerated by an illusion that simply knowing about the threat is the same thing as being able to stop it. Preparedness begins with detection. In this respect, there has been progress. Sky surveys have identified tens of thousands of near-Earth objects, and new telescopes are constantly scanning the heavens for more. The catalogue grows every year, and with it the sense of control seems to grow as well. Apophis was discovered in 2004, and since then many other potentially hazardous asteroids have been catalogued. But detection is only the first step. Seeing the bullet is not the same as dodging it. The illusion of control creeps in when we equate awareness with protection. To say that we have discovered an asteroid is not the same as saying we have neutralized the threat. It only means we know it exists. Preparedness is often measured by the number of objects tracked, but tracking does not stop impacts. The next layer of preparedness is mitigation, and here the illusion grows stronger. Scientists and engineers have theorized a range of methods to deflect an asteroid, slamming a spacecraft into it to nudge its orbit, using a gravity tractor to slowly pull it off course, even detonating nuclear devices near its surface to change its trajectory. These ideas are real, studied, and in some cases tested on small scales. The DART mission of 2022 proved that a kinetic impactor could shift the orbit of a small asteroid moonlet. It was a milestone in planetary defense, but it was not a proof of full preparedness. Apophis is vastly larger than the asteroid that DART nudged. The energy required to alter its orbit would be orders of magnitude greater. To pretend that a single test on a small rock translates into readiness against a 340-metre asteroid is another form of illusion. The technology is not yet proven at the scale that matters. Preparedness also depends on time. Deflecting an asteroid requires years, often decades of lead time. The earlier the intervention, the smaller the adjustment needed. A nudge delivered decades in advance can mean millions of kilometres of difference by the time the asteroid reaches Earth. But if an asteroid is detected only a few years before impact, the options narrow dramatically. This is why Apophis is so important. If its 2029 path had been slightly different, threading through a gravitational keyhole that pointed it toward impact in 2036, humanity would have had just 7 years to respond. 7 years is not enough. Space missions take time to design, fund, build, and launch. Political decisions take even longer. The illusion of control suggests that we could respond quickly if needed. The reality is that without decades of warning, our options collapse. Even when time exists, preparedness is not guaranteed. Deflection missions require money, cooperation, and political will. And those three things are often in short supply when the threat feels abstract. Planetary defense budgets remain a fraction of what is spent on other forms of security. International coordination is limited, with most responsibility falling on a few spacefaring nations. The illusion of control comes from the assumption that when the moment arrives, humanity will unify and act. But history suggests otherwise. Responses to pandemics, to climate change, to nuclear risk all show how fragmented and delayed global action can be. To imagine that asteroid preparedness will be different is to indulge in comforting illusion. There is also the question of accuracy. Preparedness assumes that predictions are certain enough to act upon, but orbital mechanics carry uncertainties, especially over decades. The Yarkovsky effect, the influence of sunlight on an asteroid's path, can alter trajectories in ways that are difficult to measure without sending missions directly to the object. Apophis, for example, had its probabilities adjusted many times as new data refined its orbit. Preparedness is undermined by these uncertainties. How do you convince nations to spend billions of dollars on a deflection mission if the odds of impact are only fractions of a percent, and if new observations may reduce that probability to zero? The illusion of control allows us to believe that preparation will happen anyway. The reality is that decisions are paralyzed by uncertainty until it is too late. Psychology plays a role in this illusion. Humans crave the sense that threats are under control, that someone, somewhere, has a plan. When people hear that NASA tracks near-Earth objects, or that the European Space Agency funds planetary defense programs, they assume the matter is handled. But the truth is that the programs are limited, the funding modest, the technology is unproven. The illusion of preparedness comforts the public, but it does not reflect the actual state of readiness. Apophis is a reminder of this gap. We can measure its path with exquisite precision, We can predict its flyby to the minute, but if its path were different, if it were on target for Earth, we could not stop it. The knowledge would bring fear, not safety. Preparedness also extends beyond technology. It includes social and political resilience. If Apophis were on a collision path, what would governments do to prepare populations? Would cities be evacuated? Would infrastructure be shifted? Would resources be stockpiled? Or would panic spread faster than planning? The illusion of control suggests that governments would manage the crisis with efficiency. But experience shows otherwise. Disasters reveal weaknesses, panic erupts, communication falters, trust collapses. Preparedness is not just about rockets and missions. It is about social systems that can handle fear. And here too, the illusion outweighs the reality. The irony is that Apophis itself will miss, which feeds the illusion further. When the asteroid passes safely in 2029, many will see it as proof that fears were exaggerated. They will say the scientists worried for nothing, that the world was never in danger. But that interpretation misses the point. Apophis is a warning, not a relief. It shows how close these threats come, how narrow the margins can be, how thin the line between miss and hit really is. To take its miss as proof of safety is to fall deeper into the illusion of control, to believe that because we were spared this time, we will always be spared. Preparedness and the illusion of control are locked together. One gives us the tools to act, the other gives us the comfort of believing the tools exist when they do not. Apophis exposes both. It shows that preparedness is still fragile, underdeveloped, and in need of real commitment. And it shows that humanity is prone to comforting illusions, preferring to believe in safety rather than confront the truth of vulnerability. The asteroid will pass, but the lesson is not about this rock alone. It is about the system of response that remains incomplete, the gap between knowledge and action, the illusion that awareness equals protection. In the end, preparedness must mean more than detection. It must mean real technology, real cooperation, real practice. Until then, what we call preparedness is little more than hope dressed up as strategy. And hope is not control. It is the illusion of it. When people hear about an asteroid like Apophis, they often think of science fiction. They picture disaster movies, dramatic special effects, apocalyptic skies. What is harder to grasp is that asteroid impacts are not speculation. They are history. Earth has been struck countless times, and the evidence is carved into its surface, hidden in its rocks and preserved in its stories. The question is not whether it has happened, but how often and how devastating the consequences were. To understand the threat of Apophis and others like it, one has to look backward as well as forward. Because the record of ancient catastrophes is also a record of our future. The echoes of past impacts resonate through time, reminding us that the sky has always been dangerous and will be again. The most famous example is the Chicxulub impact. 66 million years ago, an asteroid around 10 kilometers wide struck the Yucatan Peninsula. The energy released was equivalent to billions of nuclear bombs. The impact created a crater nearly 200 kilometers across and sent shockwaves through the planet. Wildfires raged across continents. Dust and aerosols filled the atmosphere, blocking sunlight for months. Temperatures plunged. Photosynthesis collapsed. 75% of species went extinct, including the non-avian dinosaurs. For millions of years, dinosaurs had dominated the planet. In a single moment of geological time, they were gone. This was not fiction, it was an asteroid, and it was the most famous, but not the only, catastrophe of its kind. Other impacts tell similar stories on smaller scales. 50,000 years ago, in what is now Arizona, a rock barely 50 meters across struck the desert and created the Barringer crater, over a kilometer wide and 170 meters deep. The explosion released energy equivalent to several nuclear bombs. If such an impact happened today near a city, the devastation would be beyond imagination. 2,000 square kilometers of forest were flattened in Siberia in 1908 when the Tunguska object exploded in the atmosphere. Trees were snapped like matchsticks, and reindeer herds were incinerated. The object was only about 50 meters wide. In 2013, a meteor just 20 meters across entered Earth's atmosphere over Chelyabinsk, Russia. The explosion shattered windows across 6 cities and injured over 1,000 people. These were not ancient events. They were recent, reminders that even small asteroids can cause destruction on a scale modern humans struggle to comprehend. The echoes of these catastrophes reach forward in time. They remind us that Earth exists in a shooting gallery. The solar system is filled with debris left over from its formation, remnants of collisions and accretions that never coalesced into planets. These rocks circle the Sun endlessly, their orbits occasionally aligning with Earth's. Some pass harmlessly by, some burn up in the atmosphere as meteors, but others strike, and when they do, they alter history. The geological record is a story of repeated impacts. The human record will one day include more. The only question is when. Ancient myths may also preserve fragments of this memory. Many cultures describe fire from the sky, gods hurling stones, or stars falling to earth. While these stories are often symbolic, some may reflect real events witnessed by ancient peoples. The Tunguska explosion, had it occurred in a populated region thousands of years ago, would have surely been remembered as divine punishment or cosmic wrath. The echoes of impacts are not only geological, they are cultural, shaping human imagination, religion, and fear of the heavens. The serpent Apophis in Egyptian mythology, the enemy of the sun god Ra, may itself be an echo of humanity's ancient awareness that chaos can fall from the sky. Looking at these past events, Apophis becomes easier to place in context. At 340 meters across, it is far smaller than the Chicxulub asteroid, but far larger than the Tunguska or Chelyabinsk objects. It sits in the dangerous middle ground, too small to cause extinction, but too large to dismiss as local. An impact would not end humanity, but it would alter civilization. Cities would be erased, economies would collapse, climate would be disrupted. The echoes of ancient impacts tell us that size matters, but so does timing, location, and luck. A strike in an unpopulated desert would be catastrophic but survivable. A strike in the ocean could devastate coastlines. A strike near a megacity would change the world in a single day. Preparedness is often undermined by forgetting these echoes. People assume that catastrophic asteroid impacts are rare, so rare they belong only in the deep past. But frequency is not the same as impossibility. The Chicxulub scale impact may happen only once every tens of millions of years, but Tunguska scale events happen every few centuries. Chelyabinsk scale events happen every few decades. The timeline of the future is written in the cadence of the past. The fact that humanity has not experienced a devastating strike in modern history is not proof of safety. It is simply luck, the temporary reprieve in a pattern that stretches back billions of years. Ancient impacts also demonstrate the long-term consequences of even non-extinction events. The Chicxulub asteroid did not simply wipe out dinosaurs. It reshaped the evolutionary path of Earth. Mammals, once small and marginal, expanded into the niches left vacant. Eventually humans emerged. Without that impact, our species might not exist. In this sense, asteroids are not only destroyers, they are creators. They shape the trajectory of life itself. Future impacts will do the same. They may not end humanity, but they may alter its course, changing the balance of power, the direction of history, the survival of cultures. Apophis, had it been aimed differently, might have been one of those turning points. The echoes of past catastrophes also serve as warnings about complacency. Before Chicxulub, dinosaurs ruled the Earth for over 150 million years. They survived climate shifts, volcanic eruptions, continental drift. But they could not survive a rock from space. Their dominance ended not because they failed to adapt, but because adaptation does not matter when the world itself is remade in an instant. Humanity often imagines itself immune, protected by technology, intelligence, and resilience. But the echoes remind us that intelligence does not alter physics. Civilization is as vulnerable to impacts as any species that came before. Our survival depends not on luck, but on preparation, and preparation is still in its infancy. When Apophis passes in 2029, it will be a spectacle. But to those who know the history of impacts, it will also be a reminder of Chicxulub, a reminder of Barringer Crater, a reminder of Tunguska and Chelyabinsk, a reminder that what has happened before will happen again. The echoes of ancient catastrophes do not fade. They resonate forward, waiting for the next alignment, the next orbit, the next moment when chance and gravity deliver another rock into our path. The lesson is simple, but uncomfortable. We are not outside of history. We are within it. The same forces that ended the dinosaurs, that scarred the deserts, that flattened Siberia still operate today. The same future that awaited them awaits us, unless we prepare. Ancient catastrophes are not curiosities of geology. They are rehearsals, and their echoes are not whispers of the past. They are warnings of the future. When Apophis was first identified as a potential threat, the immediate instinct was to ask what technology could do. Could rockets intercept it? Could nuclear devices deflect it? Could advanced propulsion systems push it just enough off course to spare Earth? The question made sense because modern humans have built an identity around mastery over nature. We build machines that fly through the sky, dive into the oceans, and explore other planets. Surely we can also defend against a rock drifting through space. But the deeper scientists looked, the clearer it became that the problem was not only technology, it was time. The technology exists in fragments, in theory, in small-scale tests. But time is unforgiving. Time is the true constraint. Technology versus time is the real story of planetary defense. Consider the asteroid itself. Apophis is not unusually large compared to others in the solar system, but at 340 meters it is more than enough to devastate regions of Earth. The energy required to shift its orbit is immense, far beyond the capabilities of small tests like NASA's DART mission. That mission nudged a much smaller asteroid's moonlet, and even that was hailed as a breakthrough. Scaling that up to an object like Apophis would require far more mass, far more speed, and far more planning. The technology might be achievable, but only if humanity acts decades in advance. Which brings the problem back to time. Without decades, the technology cannot catch up. Time shapes every option. Kinetic impactors, spacecraft launched to slam into an asteroid and alter its path, are effective only when deployed years before the predicted encounter. The sooner the impact, the smaller the nudge needed to create a large deviation over distance. But if time is short, the nudge must be greater, and at some point it becomes physically impossible to push the asteroid far enough. Gravity tractors, spacecraft that hover near an asteroid and slowly take it off course with their own weak pull, require even more time. They could work in theory, but only if decades of lead time are available. Nuclear devices are the bluntest tool, capable of delivering a massive push, but even they are constrained by time. They require precise planning, international coordination, and the political will to deploy nuclear weapons in space, all of which take years. If a threat like Apophis were discovered only a few years before impact, none of these technologies could be readied in time. The bullet would already be in flight. Apophis is not a collision threat in 2029, but the hypothetical has always been part of the discussion. If its orbit had been slightly different, threading through a gravitational keyhole, it could have returned in 2036 on a collision path. That would have left humanity with just 7 years to respond. 7 years is not long enough. Designing, funding, building, and launching a deflection mission on that timeline is almost impossible given the way human institutions operate. Even if the technology could be built, the politics would delay it. Debate over who leads, who pays, and who decides could consume precious years. By the time agreements were reached, the asteroid would be days from impact. Time would have beaten technology. This is why scientists insist that planetary defense must be proactive, not reactive. The illusion of control tells us that we can wait until a threat appears, then deploy our advanced machines to stop it. The reality is that waiting is defeat. By the time a threat is imminent, it is already too late. Preparedness requires building the technology before it is needed, testing it on practice targets, and having missions ready to launch at short notice. But this is expensive, and politicians rarely spend money on risks that feel distant. Time is ignored until it runs out. The problem is compounded by uncertainty. Asteroid orbits are refined over years as new data arrives. When Apophis was first discovered, the probability suggested a real threat in 2029. Later observations reduced that risk to zero. The same process played out with 2036. Each refinement shifted the timeline of urgency. But how do you convince governments to spend billions on a deflection mission when the odds of impact may disappear tomorrow with a new measurement? Time pushes for action, but uncertainty pushes for delay. Technology sits in the middle, waiting to be funded, waiting to be tested, waiting to prove itself. By the time the need is undeniable, time may already have made the decision for us. Technology versus time is not just a matter of engineering. It is also a matter of psychology. Humans overestimate what technology can do on short notice. We assume that because rockets exist, they can be launched quickly. We assume that because nuclear devices exist, they can be deployed against an asteroid if needed. We assume that because we landed on the moon in the 1960s, we can easily intercept an asteroid now. These assumptions ignore the complexity of real missions. Every spacecraft requires years of design and testing. Every launch requires coordination. Every deflection mission requires practice that humanity has not yet undertaken. The gap between what we imagine and what we can do is filled by time, and time is rarely generous. The tension between technology and time also plays out in public perception. When Apophis was first announced, people wanted answers. Could it be stopped? Would governments act? Scientists explained the limitations, but the public often assumed that if the danger were real, someone would already have a plan. The assumption of control became its own form of denial. Few wanted to hear that there was no plan, that the technology was untested, that only luck was keeping the world safe. The illusion of control was easier than the reality of time. Apophis was downgraded as a threat, and with it the urgency evaporated. The asteroid would pass and humanity would move on, still unprepared for the next one. Yet technology is advancing. The DART mission was one step. Future projects like space-based telescopes dedicated to asteroid detection or larger-scale deflection tests are being planned. These efforts represent progress, but they remain slow. They are tied to budgets, politics, and priorities that shift with elections and crises. Time does not shift with them. Time continues. Asteroids continue. Orbits evolve. The future impact is not a matter of if, but when. The only question is whether technology will be ready when time runs out. Apophis, in this sense, is a rehearsal. Not because it will strike, but because it shows how close the margins can be, how precise the measurements must become, and how urgent the preparation truly is. It highlights the imbalance between what is possible in theory and what is ready in practice. It shows that survival depends not on last-minute brilliance, but on decades of foresight. Technology can save us, but only if time is on its side. Without time, technology is just potential, unrealized and useless. The story of planetary defense, then, is the story of aligning technology with time. It is about building the tools before they are needed, about funding missions that may never be used, about preparing for a threat that might not arrive in this generation, but certainly will in some generation. It is about refusing the comfort of waiting. Apophis demonstrates the stakes of this alignment. If it had been on course for Earth, we would already be too late. And that realization is what makes the tension between technology and time so dangerous. Humanity has the ingenuity to survive, but it has not yet built the discipline to act before the clock runs out. When people hear about asteroids like Apophis, their minds often jump to the most dramatic possibility: extinction. They imagine a rock so large it wipes out all life, the way the Chicxulub impact ended the age of dinosaurs. But Apophis is not that asteroid. At 340 meters across, it is devastating, but it would not erase humanity. The real worst-case scenario is not global extinction. It is something subtler, something harder to prepare for, and something far more likely. The real worst-case scenario is an impact that does not end humanity, but shatters civilization. Consider what happens when a rock the size of Apophis strikes land. The energy released would be the equivalent of tens of thousands of nuclear weapons detonating at once. A city caught in the blast zone would vanish. A region the size of a small country would be reduced to rubble. The shockwave would flatten buildings far from ground zero. Fires would rage uncontrollably. The infrastructure that holds society together, roads, power grids, communication lines, would be gone. If the strike happened near a major urban centre, tens of millions of people could die in the first hours. That alone would be catastrophe enough. But the true worst-case scenario is what comes after. The world is interconnected in ways that make it uniquely vulnerable. A strike in one part of the globe would ripple through every economy. Trade routes would collapse, markets would panic, refugees would pour across borders, supply chains would disintegrate, food, fuel and medicine would become scarce, governments would struggle to maintain order, alliances would fracture. In a world already strained by competition and distrust, the sudden shock of an asteroid strike would be enough to ignite conflict. Wars might follow not from the impact itself, but from the scramble to survive the aftermath. The real worst-case scenario is not the fireball in the sky. It is the collapse of order on the ground. And what if the asteroid struck the ocean instead of land? Some might imagine that safer, as if the water could absorb the blow. But the oceans are no shield. A strike there would generate waves hundreds of meters high. Those tsunamis would travel thousands of kilometers, slamming into coastlines with unimaginable force. Cities like New York, Tokyo, Mumbai, and Lagos could be inundated. Ports would vanish. Entire nations dependent on coastal infrastructure would be crippled. The death toll would be staggering. And because so much of the world's economy flows through ports and shipping lanes, the impact would disrupt trade globally. Even countries far inland would feel the consequences. Once again, the aftermath is the real disaster. The real worst-case scenario is compounded by psychology. People do not react to catastrophe with calm logic. Panic spreads faster than information. Rumours multiply. Trust in governments evaporates. When Apophis was first announced as a potential threat, conspiracy theories immediately emerged. Some claimed scientists were lying. Others claimed governments were hiding the truth. If the asteroid actually struck, the distrust would multiply. Even in unaffected regions, fear would drive irrational behaviour. Markets would crash. People would hoard supplies. Societies would fracture along lines of fear and suspicion. The asteroid itself might kill millions, but panic could destabilise billions. Another layer of the worst-case scenario is environmental. A strike would throw dust and debris high into the atmosphere. Fires ignited by the blast would add smoke and soot. Depending on the scale of the impact, global temperatures could fall, crops could fail, food shortages could last for years. The world might not plunge into a full impact winter like Chicxulub, but even a few degrees of cooling could devastate agriculture. Famines could spread. The real worst-case scenario is not extinction but starvation. Humanity would survive, but in numbers drastically reduced, struggling through years of scarcity. There is also the question of geopolitics. Imagine Apophis striking within the territory of one nation. Others would be affected indirectly, but the direct destruction would be localized. Would the global community unite to help, or would nations turn inward, guarding their own survival? History suggests the latter. Even now, cooperation on global threats like climate change and pandemics is fragile. In the aftermath of an impact, fragile cooperation could collapse entirely. The world might splinter into isolation and hostility. The asteroid would not just destroy a city or a coastline, it could destroy the fragile network of trust that holds nations together. The real worst-case scenario, then, is a chain reaction. A single impact unleashes cascading failures, economic collapse, social unrest, political fragmentation, environmental stress. Each amplifies the others, each makes recovery harder. Humanity would not end, but the world would no longer resemble the one we know. Progress could be set back centuries. Billions could survive, but in a world defined by scarcity and fear, civilization itself could be reshaped not by extinction, but by survival under duress. This is what makes Apophis so important. It forces us to confront not the fantasy of extinction, but the reality of collapse. Extinction is clean in its finality. Collapse is messy. It is slow. It is filled with suffering. It leaves survivors to struggle through ruins, to rebuild under impossible conditions. It forces choices about who eats, who is sheltered, who is saved. Extinction is dramatic, but collapse is cruel. The asteroid's worst-case scenario is not the end of humanity. It is the end of stability. This perspective changes the way preparedness must be considered. It is not enough to imagine planetary defense as simply preventing an impact. The aftermath must also be considered. What systems are in place to handle refugees? What stockpiles exist to feed populations during years of famine? What communication strategies exist to prevent panic and conspiracy from spiraling out of control? The illusion of control tells us that if we can just stop the asteroid, everything will be fine. The reality is that even if we stop one, another will come, and if we fail to stop one, survival will depend not only on technology, but on resilience. Preparedness must mean more than rockets. It must mean systems that can absorb the shock of collapse. The worst-case scenario also raises the question of time. Impacts are inevitable given enough centuries. Civilization, however, is fragile on shorter timescales. The longer humanity delays in building defences, the greater the chance that the first real test will not be extinction but collapse. The asteroid that wipes out humanity may never come. The asteroid that topples civilization could arrive tomorrow. Apophis is not that asteroid in 2029, but it represents the type that could be. It is large enough to cause collapse. It is small enough to be overlooked compared to true extinction-level rocks. It sits in the middle ground, the most dangerous category of all. The real worst-case scenario, then, is not the dramatic fireball of total destruction. It is the slow unravelling of everything we rely on. It is a world where billions survive, but in fear, hunger, and conflict. It is a reminder that survival is not the same as safety, and that living through an impact may be harder than dying in one. Apophis forces us to look at this truth directly. The asteroid is not the end of humanity. It is the end of illusions, and that may be worse. For centuries, humanity has looked to the sky with a mix of wonder and dread. The stars inspired stories, the planets inspired myths, and comets inspired fear. The heavens were both a guide and a threat, a place of order and a place of chaos. In the modern age, telescopes and equations have replaced myths, but the tension remains. When people hear about Apophis, or Atlas, or any other object drifting through the void, the question always follows: should we be afraid? It is a natural question, but it is often answered in the wrong way. We fear what is spectacular. what captures headlines, what sparks the imagination. But what deserves our fear is not always what captures our attention. Take Atlas, the interstellar object that drew fascination. It was a novelty, something foreign, something that felt almost alien. Its trajectory guaranteed it would never strike Earth, yet it captured imaginations precisely because it was strange. People feared the unknown. They speculated about hidden dangers, about alien origins, about secrets the universe might be hiding. Meanwhile, Apophis, far more ordinary, far more local, presented a far greater danger. It was not exotic, it was not alien, it was simply a rock on an orbit that intersected ours. But because it was ordinary, it was overlooked. This contrast reveals the truth. What deserves our fear is not the extraordinary, it is the ordinary. The threats we live alongside every day, the rocks we know are there, the ones that pass not once but again and again. Apophis deserves our fear because it is a reminder of inevitability. It will miss in 2029. It will not strike in 2036. But its passage is proof that Earth is not isolated. It is proof that rocks hundreds of meters wide drift close enough to touch the edges of our world. It is proof that, given enough time, one of them will not miss. The Chicxulub impact 66 million years ago was not a fluke, it was a preview. The Tunguska blast in 1908 was not an anomaly, it was a warning. The Chelyabinsk explosion in 2013 was not just a curiosity, it was evidence. These events are reminders that Earth lives in a shooting gallery, and that survival so far has been luck, not mastery. What deserves our fear is not the asteroid we can name, but the thousands we cannot. Apophis also deserves our fear because it reveals our unpreparedness. We can measure its path with incredible accuracy. We can calculate its orbit decades into the future. But if it were aimed at Earth, we could do nothing. Our defences are theoretical, our technologies are untested, our plans are vague. The illusion of control comforts us, but it is still an illusion. We are not ready. And the gap between what we know and what we can do is wide enough to swallow us whole. What deserves our fear is not just the asteroid. It is our own complacency, our reliance on luck, our tendency to mistake awareness for preparedness. Fear is often seen as irrational, but in truth, fear can be a form of wisdom. Fear directs attention. Fear motivates action. The question is whether it is directed at the right targets. Fear of interstellar objects like Atlas is misplaced. Fear of extinction-level rocks larger than Apophis, while real, is too distant to guide immediate action. The fear that deserves focus is of the mid-sized asteroids like Apophis, large enough to destroy cities, small enough to be more common, frequent enough to represent a real risk in human timescales. These are the rocks that history has shown us again and again. These are the rocks that turn forest to ash, that throw dust into the skies, that create craters and scars. These are the rocks that humanity is most likely to face. What deserves our fear is also the reaction to impact, not just the impact itself. The asteroid that strikes will kill many, but the chaos that follows could kill more. Panic, famine, collapse, war. These are multipliers of destruction. The asteroid may be the trigger, but the aftermath is human. The real worst-case scenario is not the fireball, but the unravelling of civilization in its wake. This is why fear must be directed not only at the rock, but at our own fragility. The systems we rely on are delicate. The networks that feed us, connect us, and govern us can break under stress. What deserves our fear is not only the stone from the sky, but the collapse of order when it strikes. There is also a deeper layer. What deserves our fear is not just the external threat, but the silence that follows when it passes. Apophis will miss in 2029. The world will marvel, then forget. The headlines will fade. Funding will dry up. Politicians will move on. Humanity will return to its distractions, lulled by the relief that nothing happened. That cycle of forgetting is the most dangerous of all. because one day another asteroid will come, and by the time it is recognised it may already be too late. The real danger is not the object we see, it is the apathy that follows after we see it miss. So what deserves our fear? Not Apophis alone, but the pattern it represents. Not the singular object, but the reality it exposes. Earth is vulnerable, humanity is unprepared, the universe is indifferent, the illusion of control is fragile. The worst-case scenario is not extinction, but collapse. The danger is not once in a million years, but within lifetimes. That is the truth. That is what deserves fear. But fear without action is useless. Fear must be converted into preparation, into technology, into cooperation. If it is not, then the fear itself becomes another illusion, a momentary thrill that fades until the next asteroid appears. The choice is ours, to fear the wrong things or to fear the right ones, to fear the unknown and the exotic, or to fear the ordinary and the inevitable, to fear in silence, or to fear in a way that drives action. Apophis will pass, but the lesson it carries must not. What deserves our fear is not the spectacular but the ordinary, not the alien but the familiar, not the distant but the near. It is the rocks that circle with us, the ones that cross our orbit, the ones that will one day find their mark. They are the true danger, the true serpent, the true chaos in the sky. And until we face that truth without denial, without illusion, without complacency, we live not in safety, but in borrowed time.